do it with the chat room.
Oh.
Yep.
Oh.
Okay, well, this laptop didn't get it, so I'm very sorry. But
no,
if you want to do chat, you'll have to pull up attend.seaGL.org on either here or a phone.
Okay. I'm not.
This was supposed to. Wait, maybe it's in the web browser. It is. It's in the web browser right here. Okay.
Okay, so I can look at if I'll just check.
So your talk is Friday at 10:30. No, that's Saturday. You are open recycling?
Mm-hmm.
Great. This is your chat room.
Okay, cool. So I can just check in there. And...
Yep. So if people
remotely have questions, totally. Thank you.
Hello. Hi. Welcome to SeaGL.
No, it is 10:30. Just gonna try to think. Okay. Well, I will probably get this show on the road. Give a couple more minutes for people who might be filtering in. There we go. Huh. Anyone happen to know how to full screen a browser if my function key is not working right now?
You can often right-click on the browser window itself. And
yeah, full screen. It doesn't get rid of the window, but I've got another solution, I guess. I'm doing this in kind of a funky way, but
wouldn't be a conference without tech issues.
Yeah.
I probably should have asked that first, but I'm not too worried about it. Probably I'll throw this up on the, well, it will be a little, okay. Got one Okay, give me 1 second to see if I don't want to have a window on the top of it. If we can. Welcome. Just gonna get started in 1 second when I can. Okay, yeah, I figured it was filtering in. This is the first welcome. Morning. That's our first time in any of these rooms. No, unless you happen to. I'm trying to figure out how to. This is actually in a browser, but I can't full screen it because I don't have the function. The function key is working. Yeah, the function the key is. So I can't. I'm like, how do I do?
Okay.
But,
well, if you just present this in in post production, I will crop out your.
Oh, you know what? No, I think I've got an idea. I think I can. I'll just drag it to where it needs to be and tie it away.
Okay.
Actually, yeah, never mind.
If this needs any post-production editing, I'm the guy that does that. So
cool. Awesome.
I will take care of whatever.
I like putting ourselves in a position where you don't have to do that.
Well, thank you very much. Thank everybody for coming to SeaGL.
Firefox, right?
This is actually Brave. It's really hard to see, but I want to drag that. Oh, out. Something. Okay.
This is a 30-minute talk.
No, I don't want to. Just trying to screen that.
Yeah.
Make it a little bigger.
11 is one.
Just about.
Thank you.
Oh. Awkward things. That's better. Okay, that's mostly gone and a little bit less distracting. Just a little bit more. Okay, awesome. Thanks y'all for coming. Thank you to SeaGL and all the people that make it happen. Give yourselves a round of applause. You made it. Have this set up so I need to also talk. Reminder that I need to talk here. I like to kind of move around a little bit, but nice rhetorical question to start. Is the project still open source if there's no one around to use it? This is kind of getting at, like, if there's no forest, are there trees, right? Because if our environment doesn't exist, then we're not going to be. If we're not alive to use tools, what's the point, right? So that's kind of the backdrop is sustainability, thinking about making sure we can survive on this planet, of course, and open source. So everyone probably knows that term, FLOSS. And then I also like to, a lot of these concepts apply to not just software. So of course, flow is a kind of a more broad version of that. So if there's no environment, right, if the world is uninhabitable for us humans, then we won't really have open source development at all. So how do we both sustain and flow, to use it in a punny sense? We want to have a thriving and healthy ecosystem for us all. So the first step, survive. Could go ahead and check that one for now. Obviously that's a really big topic. And I'm gonna zoom in on a few things and just try to contextualize it with the perspective that I have on the number of things that I think are pertinent and where I can help. Obviously, there's a million things to do, but the first thing is to kind of take a step back and say, what is this about? Okay, this is a huge global issue that's hard to even think about for a lot of people. It's like emotionally charged. And so, having a positive frame of mind and thinking about things and how do we not die would be probably a worse way to put it. So I try to frame things as how do we thrive, right? So step one, we have an infinite amount of resources. How do we use them well? Or step 1A, that's kind of the second part of that, which is like chicken or egg, is like, what do we do with the leftovers? Food waste in America is particularly bad. I could get, there's a lot of stats. I tried to keep this simple and avoid stats, especially because they're just overwhelming. Um, so I'm gonna just focus on the little things that can add up, basically. And we don't want, all of our trash to end up there. Everyone, I'm assuming people are familiar with the floating island of trash. It's like, we don't want that to become the biggest country in the world. Hopefully that can go down, obviously, but this is a large-scale problem, as we've talked about. So obviously recycling is important. I'm going to focus on the recycling, the recycling R, which there's the reduce, reuse, recycle. We all know that. And recycling is kind of like the more amorphous thing, because a lot of, reducing and reusing is technically part of the larger sense of recycling. But what does it mean to just do that one R, which is recycle, which means, basically trying to put things back in the system that may or may not do something with it well. But that's the idea and the intent behind like the blue bins. So my framing is that, we live on an ecosystem and nature does a really good job of recycling things. And it's kind of like how the difference between soil and, soil is like basically dirt where it should be, and dirt is just soil where it shouldn't be. So that's one of the framings that I think is really helpful, is we need to get things where they'll be useful and not put things where they're problematic, like the ocean. So another kind of differentiation is supply side versus demand side. So like consumers versus manufacturers, because they both have their own forms of waste and ways of recycling. There's a lot of waste on both sides, and again, they're kind of a multifaceted thing. So demand side, lots of recycling efforts have obviously been made, but that's I'll get into a little more detail, but basically, we have these blue bins in the Northwest, in Oregon, and China. Does anyone know where they go now? They used to go to China, then there was a national sword policy that was implemented, which meant that they started being more discerning about the level of, because basically a lot of this, I think it's like a small piece of food waste in an entire bin basically wasted it, because it made it that much harder to recycle, especially mixed use recycling. And that's one of the difficulties of demand side or consumer side recycling, is that there's just so many things, and you have to either have a bunch of separate bins like they do in Germany. They have 5 different bins, and basically every point where you can throw something away, there's 5 different bins. And so they've done a good job of making sure that people throw things away in the right bins. And that can be difficult because people don't always follow that. And that's where, those bins are for like mixed use recycling, and they of course have to be unmixed. And again, if they're tainted by food waste, so it is work even to do this correctly with the mixed waste, with the mixed recycling system. So yeah, those all go in the garbage now. They go into landfills, and that sucks, because people still feel good about that, differentiating between garbage and recycling, but it's just not true, unfortunately. Some things are, so recycling is both hard and easy. There's, lots of things that you can do simply and reuse. Plastic bags, you can just reuse plastic bags, but there's of course so many plastic bags that you need. Paper bags, it's another, I won't get into the whole paper bags versus plastic bags, because they both have environmental impacts in different ways. But there's basically, if you think about the location of, where a recycled component is exiting from and where it might be used. If it's a really far away, it's not going to be tenable, because the shipping costs and all of the energy that goes into that is a complicated dynamic that doesn't really scale very well. And then, so plasticity, like the word plastic, is basically like how easy is it to modify it or change it to make it something else. So plastic is very plastic, and that's awesome. I'll come back to that. But the reason there's this little space station here is because certain alloys and metals can be basically reused, and generally as you reuse something, the quality of it goes down and down, and in space stations and structural things that are important for it to be really strong, like metals, they have to be really pure, and they have to have like the batch number and where it was made, and so that makes it would be hard to recycle some alloys and put them in space stations. It's just more energy to do that. So that the term of is downcycling or cascading. When you basically have a high grade something or other, usually metal, you reuse it again, it tends to have some contaminants, and then the uses are less, you have less versatility of uses, but it's still, so you can't maybe use structural metals for like actual structures, but you can use it in something else. So a really good example is the precious plastic movement. So like go to their website, it's actually all very clear. And so they actually have this system, and there's many different kind of elements to it. And I think this is a really good model to pay attention to, because plastic, what you can easily do with it is basically shred it up and then extrude it, and then you can 3D print with it. So you can make a bunch of awesome parts, things that are needed, especially things that would just be, we don't want to use more gasoline to make more plastic when we have so much plastic here. So that's a really good, I really appreciate what they're doing, and they do have open source hardware, and they even have open source business models, and that's like a lot more rare to see. So the documentation, everything about that is very approachable for people who are not technological, because some of those machines, can be complicated, but you can just be like a donation center, and that can be like one aspect where you just collect certain, plastics from your community, and then you can find a home for it, and they help you do that. It's a network, which in that way I think is really important to think about. Also, how am I on time? Okay. So 3D printing is an additive form of manufacturing because you just add layers, basically. I'm going to zoom through this a little bit more. And it is a form of CNC. But a lot of times people talk about CNC as being mills, which are, for cutting metal and all that. And then there's also like wood router CNCs. And so that's a form of subtractive manufacturing. So you start with something and you subtract from it. So you cut away or laser cut different things. So that's like, there's the picture of a wood router CNC. So these are becoming a lot more prolific, just like 3D printers are a lot like they're enjoying they're getting really widespread, which is great if people are using not fresh plastic, hopefully. But this is really awesome because it allows people to make things and instead of having them shipped from some other place. So and I missed one. But I think this slide disappeared. But so there's a term of the democratization of manufacturing, and I think that's a big concept to keep in mind, is that we are able to empower ourselves to make the things that we might need, especially when we can source those, something locally, and depending on what type of materials you have, it can be a lot easier to use that. So this is actually something I cut, and if you have like square rectangular shapes, it's a lot easier to basically set up a machine to use that shape. But what if you have like very complicated weird shapes? Like there's lots of manufacturers that have weird idiosyncratic parts that I might be really useful or made out of something that could be reused and reshaped. And so CAD, which means computer aided design or drafting, that's a way of like virtually, simulating the model in 3D. And there's lots of great softwares out there for that. CAD, because of 3D printing and laser cutting, those are pretty straightforward of a process to go from a model to making it in reality. But there aren't so many good CAM softwares for CNCing, and that's a niche that I'm hoping changes soon, and I'm trying to help with that. But for all these let's say, I'm just gonna check my time. Okay, so the idea, this was kind of birthed from, I worked at a place on those big mills, and they got rid of a ton of aluminum and a ton of really nice wood, and it just would go in the garbage. And leather, oh my gosh, thousands of dollars of leather. And it's really sad because it's like cows lived just to be wasted. And it was like good reusable, it was reusable, but for a lot of businesses, it's just not financially viable to take the time to do it. And so like, the Amazon thing, or there's, the questions about what Amazon is doing with returns is that's the sort of thing that it gets at. Because unfortunately, a lot of businesses don't want to take the time to reuse parts or to set them aside to give them to someone else. But the idea that that could be born, in my opinion, is the idea of like open recycling, which is, basically like, if you're going to throw a bunch of things that might be usable to someone in the garbage, simply like allow people to know that that is happening, and then you could set it next to your dumpster or set up a pickup time so like companies don't actually have to take much energy to maybe get rid of something, and they could just set it, it's kind of like people do this with certain things, like pallets often will just sit next to the garbage, and if someone takes it, they take it. But there's so many other sources, like, and this is also standard for some plastics as well, because people know that plastics are more reusable, but it's not as common with metals. There's, obviously scrap yards, but scrap yards don't give very much because it's time consuming and money consuming to do that. So most of the time companies will say it's actually not worth our time to take a bunch of material to a scrap yard, unfortunately, because they don't get paid very much for it. So to come back to it, obviously we're an open source, free Libre open source conference. We all like to share. And so in my opinion, the least that we can do is share some of our garbage so that it can become not waste, because it doesn't have to be, because anything can be reused. It's just a matter of how much energy has to go into something to make it useful again. I wanted to leave time to talk, and I think we might have some. That was a little bit rushed on my part, but I would love to hear from you. These are just ideas that I've had that are kind of obvious to me, and it's a niche that I've never, people don't talk about recycling very much, but obviously sustainability and open source have a lot of commonalities, and are in alignment in terms of like, we want to live on this earth and continue to make great software and to live healthy so we can do that better. 10 minutes from now.
Well, that's now it's 8.
Okay, great, which means I wasn't sure if I needed to bail out here. So I definitely wanted to talk, to leave some room to talk. Obviously, if there's any questions, but thank you all for listening and coming. Yeah, any questions that come up? There were so many rabbit holes. I was trying to like really hone in. I did it like, there's just unfortunately there's a lot of aspects to all of this. So I was trying to hone in on something that I knew about that that there was a niche for. And I think that when I thought about the idea of open recycling, I realized that's not something that's talked about. People talk about content like open source software. There's the open works definitions of many different things that are open related, like open music, all those things, but people don't talk about open waste or open recycling. So I thought that was an idea worth bringing forward. So, yeah, anyone have any questions?
I have a load of e-waste, and I'm just hoarding it because I feel guilty about it.
Okay.
Do you have any suggestions?
Yeah, so in Portland, we have a place called Free Geek. And those places, I'm sure there's one in Seattle, but they will generally take electronic waste. So electronic waste is something that is generally, because there's a number of things that are valuable enough that it justifies the cost of taking them apart. So Free Geek I don't know what it would be in Seattle, but that's definitely something that exists. It's there's like more of a niche of just like random metal scraps. There's just 1,000,001 manufacturing companies that are smaller scale that aren't going to take the time to figure out what to do with the things that might be useful. And so setting a precedent, ideally, a network where we could document things that are reliably being thrown away, because if it's just a one-off, if it's just like a handful of parts, it's not very useful to take the time to model them up and think about a way they could be reused. But if it's something that's constantly getting thrown away, then that's where it's viable to spend the time to do that.
Seattle is RePC.
RePC?
RePC is a place.
Yeah,
that
that sounds like a perfect place to go. Yeah.
One interesting solution I've seen for food waste that kind of reminds me of what you're talking about is Good to Go is an app. Restaurants at the end of the day, when they've got all this leftover food, you can sign up. It's like $5. You go in and they just give you something. You don't know what you're getting.
Cool.
Like, I don't know, just an interesting idea where, they can get a little bit of money. You might be able to say, I want metal, I want wood, I want whatever.
Yeah, that's the exact type of thing. And so there's a lot of places, because food is such a scarce resource that's so important. There's a lot more infrastructure and time that people have spent doing that and making sure that doesn't get wasted. In France and Germany, it's actually illegal for grocery stores to throw away. So there's trucks that will actually take food and deliver it to straight from the grocery store to people's homes, and it's like, that's great. That's a phenomenal precedent. I'm really glad that that's happening. Where are other places like Food to Go? Okay, great. That sounds like I'm assuming that's a company.
Good to Go. It's an app you can just download and
and so they charge money, and that helps them justify costs, and that's good, because then that's one step in the right direction for sure. And I think that our infrastructure should be built around that. A thing about recycling and not having a huge environmental impact is being local about things. So sourcing local food, you don't have to use as much plastic in order to ship. Because that's one of the things that plastic is it's really hard to imagine it going away for raw meat or something that's not being handed directly to someone. So yeah.
Do you know any makers? I'm not really involved in the maker space, but that's a spot where I could imagine a small piece of metal. If I'm seeing it, I could use that.
So scrap bins, scrap bins are totally a thing. I actually do CNC and project management for a makerspace in Portland, and then do contract milling and other admin stuff on the side. So yeah, there's usually, especially with wood, there's always a full scrap bin. So you can just you need a piece of wood, go grab it. It's more of, some makerspace, that's where people know they want that generally, but there's probably a lot more. And then also another good example is mill end pieces. So at a hardware store, you go to buy wood, there'll be boxes where you pay a cheaper amount because it's not a standard cut of wood. So those are some good small examples. But yeah, totally.
Do makerspaces make any relationships to get those scraps? Is that something?
Occasionally. And that's the type of thing that that I feel like needs to happen more, so that I'm trying to do that. So I've been building a relationship with the manufacturers that I work with, so that, and I just had to do it with people. Like I talked to the top level folks, and they're like, "That's great, go ahead and do that," but someone has to like set aside the things, and someone has to throw. So like this literally was born out of me seeing things thrown in the trash and be like, "Hey, is there any problem with me grabbing that from the trash?" Because there's all these like nice aluminum keyboards. A note that I meant to make is aluminum. It takes like 5% of the energy to recycle, as opposed to other alloys and metals that they take a lot more energy to reuse. So aluminum is relatively plastic in that sense, and that you can repurpose it easily because you can melt it down.
Yeah, so I know there's like one, this isn't really, but there's a company in Korea that's trying to recycle used car batteries, and the big concern is like safety. So
Right. Yeah. So, and I forgot, I'm supposed to be re-mentioning the question. So, you were mentioning a company in Korea that is trying to recycle car batteries. And yeah, that is a whole. So, in talking about like cascading or downcycling, there is some. So batteries are a tough one. I'm glad that someone's doing that. The other thing I think about is like nuclear power and plutonium, because there are some recycled there are some applications for used plutonium, but it's like probably one step of being used, and then what happens after that. And that's where it's like thinking about what we use and how we use it, and can it be reused. And that's one of the things that always drew me personally to like open source, because like thinking about hardware and thinking about all the, a bunch of e-waste that it's like really hard to repurpose, especially if it's proprietary, schematics. But if you know what's on the board, and that, there's, or trying to design something that is, hardware that can be reused, like that's difficult, but that'd be awesome. So thank you all for being here. Appreciate your thoughts. And I didn't mention this, but I will probably set up some stuff that I made all with Blender Cam on my CNC. So I'm gonna have some like examples, and I'll get out of the way. But do come find me and talk to me, and if you, I'm friendly. I don't bite.
Do you have HDMI? It's going to work what I have to do. That's promising. Hey, slides. Okay. It's over here. I'll take this off. It's time to start, isn't it? Just get going. Yeah, okay. Hello, everyone. My name is Tim Sample. I use he, him pronouns, and I want to talk to you about GNU Geeks, which I've titled here, The Other Functional Package Manager, because we're very similar to Nix, which is software that's much more popular than we are. So we're kind of in this niche space. You may have heard of Nix. Maybe you don't know as much about Geeks. I want to share some interesting things that we do differently. They gave us, as a speaker gift, this weird little keyboard thing. And in true hacker spirit, I have it controlling my slides. So there we go. Hey! So a little about me. I've been programming for a shockingly long time now. And since the beginning, I've been using free software, GNU+Linux. I got into Geeks about 7 years ago, just about, and started contributing right away because at the time it needed lots of help. So you start using it, you're like, oh, this thing, I need to do something. So I got right into it. For the talk, I'm going to give a few disclaimers. The first disclaimer I'm going to just give right now, it's going to be a bit of a whirlwind. I apologize. I probably should have taken an hour slot. I'm just going to talk really fast, and that'll solve it, right? And then after the disclaimers, we're going to talk about what is functional package management, because Geeks is a functional package manager. So what is that idea? And then we're going to talk about some things specific to Geeks. Geeks uses scheme, quasi-quotation, G-expressions. What are these technical things that Geeks does differently? And then we're going to talk about some free software things, some hacking, and like how you study code, some cultural and philosophical things that Geeks does differently. So we'll get the disclaimers out of the way quickly. I'm not going to like go through everything point by point. This is what Nix does. This is what Geeks does. This is yeah. I'm not really a Nix expert. I've been a Geeks user from the start. I think Nix is great. They pioneer a lot of the stuff that we use in Geeks. So I don't want to put it down or anything. I just want to share what I like about Geeks. And I wanted to cover this because I see this misconception sometimes that Geeks is like a fork of Nix. They started with the same code. We share a little bit of code. We share the same paradigm. We're both based on this PhD thesis that came out in 2006, I think. But that's it. It's not really a fork in the technical sense. But we'll skip that. That's just so you know, and you can clear that up if you see the misconception out there. So what is functional package management? What is this idea here? Simply put, and very quickly put, basically the idea is you model software building and software installation. You got a package, you got to build it, you got to install it. How do you do that? You model it as a pure function in the mathematical sense. What does that mean? It means that you have no side effects. So you don't affect things that you don't know about. You don't use things that you didn't talk about. You're very precise. And the way that we ensure that in both Nix and Geeks is that you do all the builds inside of a controlled environment. It's like hermetically sealed. Nothing gets in or out without you knowing about it. At least that's the idea. Right? Like a container in the modern parlance. And why do you do this? It's actually quite a lot of work and very difficult, but why do you do it? Well, you get a lot of really cool features, and they kind of just fall out of the model. So you get transactional installs, things are atomic. You get rollbacks. If you don't like what you install, you can go back to how your system was before instantaneously. You get parallel installations of different versions of software. You can have different versions of libraries on your computer, different versions of software. You can have temporary environments like virtual envs in Python. So like you can set up a development environment for whatever software you want. If it uses C, C++, Rust, doesn't matter. You can set up a virtual environment for it. You can do all of this without being root, which is cool. You can install software. You can uninstall software. It only affects your user. You get this kind of subtle thing, but I think it's super cool, source binary transparency, which means that Geeks is modeled like Gentoo or the FreeBSD ports tree, where everything is source code and you build it all from source. But then at the same time, you don't have to build anything from source because you can get binary substitutes over the network. They build them on the Geek side and you get them. And it's all transparent because we know enough about the package graph and the package system that we know which binaries correspond to which source code. So you get the flexibility of the source-based distribution with the convenience of the binary-based distribution. And then, yeah, the last thing you get is this really deep insight into the package graph, right? Because you have to declare accurately all of your dependencies and because you know where all the outputs go, you have a really accurate model of how all the packages interact with each other, what depends on what, where the sources come from. You can do really cool stuff with like software bill of materials. I'm not going to get into that, but you can ask me about that later. And then this is kind of specific to Geeks, but you end up having these two views of the package graph, which I just mentioned. And one of them, and I got to lay this foundation for later, so bear with me. One of them, you have this high-level view of the package graph, so you have these objects like a package, right? It's software that you can install on your computer. You have an origin. It's source code. It's the source code of the package, okay, where you get it from the internet. And then you have some little helper utility nodes in the graph, like you could have a local file that comes from your hard drive. You could have a computed file that you derive, in place, that kind of thing. And then you have the low-level package graph, which is what happens on the build side in the hermetically sealed container. So on that side of things, you have just derivations. Everything's a derivation. But there's kind of two types of derivations. There's the real derivations, which derive something from something else, right, as you'd expect. It's a script that takes some inputs, gives you an output. And then there's fixed output derivations, which are actually just data. And we use a cryptographic hash for that. And we say, this is the data that you get. It's probably source code. It could be other things, usually source code. So that's functional package management. Hopefully you had some knowledge of it before. I know that was a brief introduction, but that's what we're going to be working with. So I want to talk about Geeks and its use of Scheme. Because honestly, when I got to Geeks, I was not a schemer, didn't like Lisp, thought it was all stupid. And I know lots of people do.
Look at you now.
Look at me now. Everything's changed. I'm wearing the shirt, right? Like, yeah. I'm here to spread the good news. No. Scheme actually is a really good choice in this domain particularly. You know, maybe it's not a good choice in every domain. I like it now, but I understand that there are different tools for different occasions. But in this domain, it actually is a really good choice. And so Geeks is written in Scheme. All the like command line tools and everything, all Scheme. The packages are described in Scheme. All the packages are just Scheme scripts, Scheme modules. And then all the packages are built with Scheme. You know, when you invoke make or the compiler or whatever it is that you're cargo, whatever it is that you're invoking on the build side, that's all Scheme scripts, Scheme top to bottom. And so in contrast, and I said I wasn't going to do a lot of contrast, but this is the one exception. In Nix land, the command line tools are C++. The packages are described in a domain-specific language called Nix. And then it uses bash for a lot of the build script orchestration. And so what is Scheme? If you've never heard of it, it's kind of like Lisp, lots of parentheses. It's old, very old, created in the 70s. And the two features that I want to highlight about Scheme that I think Geeks uses to good effect are its support for syntactic extensions, which are also called macros. But right, you can change the syntax of the programming language to a limited extent, but it's useful. And it's also very good at creating and manipulating Scheme programs, right? Lisp is an old school AI language. It needs to manipulate the stuff of its own thought. The stuff of its own thought is code, so it can create and manipulate code. And Scheme can do the same thing. So this idea of syntactic extensions gives us this feature, which is embedded domain-specific languages. So if you have a normal domain-specific language, you know, you can tailor a language to a specific problem domain, and then you can have these really tight solutions to certain problems in that domain, which is great. It makes a lot of things easier, but it makes some things a lot harder because you don't have the generality of a full programming language if you want it. The embedded domain-specific language tries to solve that problem by putting those tools to make a certain domain easier inside of an environment where you have a full programming language. And sometimes the compromise there is you don't get quite as nice of a fit, but you get a pretty good fit, and you have this escape hatch to general programming whenever you need it. And so I want to give a brief example. Again, I apologize for the whirlwind, but we have a short amount of time. So this is Scheme programming. I import some Geeks modules, so I have access to the Geeks API, Geeks libraries. And this is manipulating a package object. So I want to make a new package object based on an old one. I bring in the GNU hello package, right? I just bring it in by name. And what I say is I want to have the same package as that one, but I want to change the arguments. And in fact, I want to change the phases. Builds happen in phases. You have to unpack the tarball. You have to run make. You have to maybe run tests, whatever you want to do. I want to change those phases, and I want to, just before we build the software, I want to add a phase called patch SeaGL. And in that phase, I'm going to use the substitute procedure, which is like running sed-i, right? It's going to replace text in some files. And I'm going to replace the word world with the word seagull. And we can actually run this, a live demo, get my shell going. If I run geeks, well, let's see, am I in the right directory? Yes. Geeks, build f, hello.scm. It's going to build this package for me. Now, I'm not even on the network. I've built this all ahead of time, so it happens instantaneously because it's cached, but that's okay. That's going to make our talk go faster, right? And what I get if I look at this, if I just run find, here I get this is the output of the hello package, right? It's got a bunch of translations, stuff that you'd normally see all over your hard drive, but it's all built into this one output because of our functional package management model. And what I want to do is run this binary, which is right here. Let's get that. Oof. You know what? I'll do it this way. Where did I go? There it is. And we'll run bin hello. And with any luck, it prints hello seagull. Hey, hey. That's a classic example, but I think it's a good one. I love it. So moving on to the other feature that Scheme has that I think is really well suited to this domain is this whole good at creating and manipulating Scheme programs thing. So Scheme has a feature, just like Lisp before it had this feature, which is code quotation. So if I just write +11 like that, this is invoking the plus function on the arguments 1 and 1. Well, Scheme says 1 + 1 is 2. That's fine. Easy peasy. But if I put a little quote in front of this, right here, that says, I don't want you to actually invoke this code. I want to talk about this code, like a quotation, right? I'm talking about the code itself. And so as a value, I get the code that adds 1 to 1. And it's not a string, it's like actually the abstract syntax tree for this code expression. And all I have to do is add 1 character, right? That's the good at creating part, is this is 1 character. It's built right into the language. But it actually does better than that. And here I write, it's really good at creating and manipulating scheme programs because I can define, so I just define a variable just for example purposes. If I do the normal quote and talk about that variable, well, it's just a quote, right? So it doesn't actually refer to the variable. It's just X. It could be any X. It's a free variable. But if I have this backtick, I get a code template. And I can fill that template with other code or other values that I have in my environment. So I can write this, and I can say, bring in X from the environment. And this is actually a static piece of code that has no variables. It just adds 1 and 2. And so with this feature, with this quasi-quotation, with templates, code templates, I can build up code expressions inside of code, much like, it's a little bit like if you're doing SQL, right, and you have like a prepared statement and you can fill in prepared statements. It's like that, but just with a much nicer interface. And so code staging is the kind of the final feature that you get out of this. And code staging is like rocket staging, right? You start with one stage of rocket, move on to another stage of rocket. Code staging, you have one piece of code that creates another piece of code that you run, and then you run this other piece of code often in another context. And like a really familiar example of this is if you're writing for the web, right? You might write code in Python, say, that generates code in JavaScript, say, and then you send that JavaScript code across the network to the client. Client runs the JavaScript code. That's code staging. It's difficult in that environment because you write the JavaScript code as strings in your Python code, and if it was all scheme, you would do it with code templating. And Geeks makes use of this to cross this divide into the build environment, which is hermetically sealed. So that's code staging, right? You have code that is your package description, and that code generates code that works inside the build environment, stage 1, stage 2. And inside the build environment, it builds and installs the program, which is great, but this is a huge oversimplification because remember earlier we talked about the high-level package graph and the low-level package graph. Well, in the first stage, you have the view of the package graph that's the high-level one. You talk about packages, you talk about source code, you might talk about local files that you have that you want to import, but then on the inside the build container, you're restricted to just talking about derivations. That's all you got. So it's pretty clunky if that's all you have. You have to prepare for this translation all the time. It's super annoying. This slide is what I was just talking about. So we got to cross this divide somehow. And that's what G expressions are about. So G expressions, when you do your code quotation, Geeks is going to keep track of whenever you refer to a high-level package object or a high-level any kind of package graph object. It's going to keep track of that as part of the code template. And then when you move it across this divide to the build environment, it's going to take all of those references and lower them down into their equivalent low-level representations. So you talk about what you know, high-level stuff. Geeks takes care of the rest, makes it low-level stuff, and it's all automatic. And I'm going to give you a quick example. This one might be a little hard to follow, sadly, but we'll do our best. The manual has like a really short example of G expressions, which is nice. And if you don't get this, go look at the manual. This one's a bit more complicated. I had a third stage of code, which maybe was not necessary, but here we go. So I bring in 3 packages, and these are high-level package objects. And I do this, I search for them with this specification to package procedure. And then the next thing I do is I manipulate these. Let's get rid of that region. I manipulate these, I use file append. And file append says, I don't want to talk about the whole package, I want to talk about it like a specific file from the outputs of that package. So I get the binary for bash, I get the binary for sed, I get the binary for hello. And then I can start writing G expressions with using these high-level objects. So this piece of syntax here introduces a G expression, and this is like the code template introduction, right? And the code that I'm staging is the string append. I'm going to append a bunch of strings together. I'm going to make a little shell script that the Linux kernel is going to understand. And I'm going to bring in as a high-level object, and this syntax is what brings it into the template, I'm going to bring the path to the bash binary, right? So I'm going to have the shebang, and I'm going to have the path to the bash binary. Then I'm going to call hello. I'm going to pipe that into sed. I'm going to do the same replacement that we had before. And this is a variable, right? I call it script code because it's staged code. It's a snippet of code. But it's not good enough to go into the build environment as it is. It needs to do a few more things. So I'm gonna build more around it. And so I'm gonna have another G expression, and this is gonna be the final build script. And what I'm gonna do is I'm gonna write to the output file, which output is just magically where the output goes. I'm not gonna explain that. And what I'm gonna do is I'm gonna display, and then I'm gonna inject the script code. So I'm composing little snippets of code into a larger script. And these could be more general. These could be returned from functions. It's fully composable. And so what I'm going to do is I'm going to write that script code, the result of running the script code, to the output file. I'm going to mark it as executable. And then the final thing that I say is I want to have a computed file. This tells Geeks that I want to make an output based on some script. And I give it a name, and I say use this script that I just wrote. And so if I go back to the shell, I can write Geeks build. If I can type gexp.scm. And what it does is it makes a script for me. And if I look at the contents of this script, which we'll do like this, you can see it has the paths to each of these different packages. So they get built, they get installed into an output, and the G expression machinery takes care of, for me, finding like this actual file path. So I just say, there's a package, and the package has some file, and Geek says, okay, I know I need to build this package. I need to figure out where it is. I need to point to the binaries. And so it builds this script for me, and I'm going to move past this. It builds some other scripts that we could look at, but I don't think we'll have time. And so I'm going to run it really quick for the sake of the example. Same thing, just different machinery. Yay, demo. So to summarize about Scheme, I think that the macros, the support for syntactic extensions, enables this embedded domain-specific language technique, which has been really fruitful for Geeks. And I think that code staging and quasi-quotation is a natural fit for a situation where you're building code, that's going to run in some other context, which is what we're doing with these hermetically sealed functional package managers. And I think that G expressions are a really beautiful way to do that when you have to look after both of these levels. But I want to move on to talk about a few cultural things. Specifically, Geeks' relationship to software freedom. Geeks is a GNU project, which is like a mixed blessing, to be honest, but it does mean that it has a very strong stance on software freedom. Here I put freedom in quotations because, again, going back to this is not Nix versus Geeks, and I don't want to say that Nix is not free software. It is, and they're wonderful. I don't want to imply anything like that. I just want to say that when we talk about software freedom in Geeks land, what we mean is that we follow the Free Software Distribution Guidelines, which is a document published by the FSF, I think, or maybe GNU, but it basically says that all of the software in your distribution is free software. And so we refer to a lot of other software, stuff like the Linux kernel and things like that, and we don't take the stock Linux kernel because it has support for loading binary firmware blobs. And we say we want to avoid we don't want you to be in a situation where you accidentally do that without knowing about it. You're welcome to do it, but we don't want to like sneak it in there on you. And so we commit to this baseline of sort of like an extreme take on it, and it lets you have the flexibility to do what you want. I think the point that makes us the best is this last one, that if you have a free system, completely free top to bottom, you can always add whatever you want to it. It's harder to like take something that's a big melange of whatever and make it be completely free. So it's nice to have a baseline. But I want to talk about this one thing that I've been working on. I want to fit it in here. And I think I have like a different sort of take for you today, which is that before we talked about, you have this insight into the package graph. You have all the packages, all their dependencies, all the source code, software bill of materials, whatever you want. It's all there, and it's all reified in this code package graph that Geeks gives you. And when you have that, you can poke at it, and you can look around and say, what does this do? How does it work? And you find it's a directed acyclic graph, which means that it has roots. There's things at the beginning of the graph. And you say, well, what are those roots? Well, roots are things that can't be derived from other things, which in some sense means that it's software that can't be built from other software, which means for the initial system, it means you have binary blobs. You have some, like, you know, you might have a C compiler or a copy of make that's statically linked, and it's how you start building all the other software. And so geeks, you know, you look and you see this, and in the geek community, we say we should minimize those because well, here, I'll explain here. No, I won't. I'll explain now. In geeks, we want to have this property of auditability. We think that you should be able to look at how your software gets built, and we think that we should remove barriers to that. So the goal is to minimize these things that are hard to audit. And Geeks has made some amazing strides in this domain. So one way you can make progress is by taking these roots that may not be strictly necessary and get rid of them. So a common way to build Java is to start with Java and then just build Java again. But that's kind of like a circular loop. So Geeks has found a way to start with C++ and get to Java. And that was something that, as far as to my knowledge, nobody else knew how to do. And Geeks sort of resurrected that path. And we've done that with OCaml recently. Some folks from Geeks, and I think some other folks, built an OCaml interpreter that runs in another language that can bootstrap the OCaml environment. And we've done it with Rust. There's this wonderful project called mrustc, which is a Rust compiler written in C++. Eventually, we might be able to use the GCC Rust. But anyway, the point is that we don't have to use Rust to build Rust. We don't have to start with a Rust binary to get a Rust compiler. We can start with other software that we have source code for and get to Rust without having these intermediate steps. We have a lot of work to do because it's popular for language designers to use their own language to build their own compilers, and it incentivizes building these loops. So we have a Haskell binary blob. We don't have Kotlin or C#, but largely because we're nervous about the binary blobs. And then the other thing you can do is simplify the necessary roots, which means that, you know, how to get to maybe C or some like baseline language, and get rid of the sort of roots at that system. And the history there with Geeks is that we started with about 250 megabytes, kind of like you imagine an old school Debian system, like the whole thing. And you start with that and you start building out the rest of the software. And through simplifying the compiler and the utilities, we've cut that in half several times over the last couple of years. And this is what I'm working on currently. So hopefully I can publish some more results there soon. Yeah. And then, so this is my fresh take for you. Wait, I missed a slide. Whip, whip. So bootstrapping is usually considered a security consideration, right? If you can't audit software, how do you know it's safe? And Ken Thompson presented this trusting trust attack in the 70s, and it's sort of a well-known thing in certain circles. But basically, you need to have auditability as a security property, right? Which is great. But I also think that, right, as free software people, like the freedom to study is one of our core tenets, really, right? And so bootstrapping is the freedom to study, but it's the fully transitive freedom to study. You don't just study the source code that you're interested in, you study the source code that makes the source code you're interested in. I'm running out of time. I want to rip through this example. Ken Thompson gave this example in the 70s, and when he did the trusting trust attack. If you want to know what \n means in C, right, it's how do you get a new line and a character value. \n, what does it really mean? Well, you open up your C compiler source code, right, because you have the freedom to study. And what does it say? Well, the C compiler source code says \n is \n. And you're like, well, what does that mean, right? Like, what does that mean? And the only place that the definition, the actual like numerical value of \n exists is in the binary of your C compiler. And so you can't actually use your freedom to study to figure this out. You have to refer to other, you can't figure it out, but it's not in the source code itself. And this is a contrived example, but you could imagine it in bigger situations. And I think that we can and should do better. So in summary, Scheme is a cool choice. FSDG is nice for building a baseline of freedom that you can work with. And then the design and cultural values of Geeks really have made some strides in terms of providing people with more freedoms. Thank you. I think I'm pretty short on time. Maybe I have time for one question, if there's a question. Yes?
One question about packaging programs.
Yep.
Besides Geeks import, do you have any tips for packaging programs like Go programs that might have like 200 dependencies? And then you got dependencies and get into dependency hell. I tried packaging some Go exact thing. You should package all the dependencies themselves.
Yeah,
And Geeks Import did do a fantastic job of specifying the scheme code for it.
yeah, that's not great, and that's too bad about Geeks Import. So in that, if it were me and I was in your situation, I would start by looking at the Geeks Import code, because I have improved import for certain like other package managers before, and that's helped a lot. Second of all, you can sort of stop worrying about upstreaming these package definitions, and so you can get kind of uglier ones for your own use to start, which is another thing that I've done in the past with JavaScript, right? So you can just pull in these just tons of dependencies, and maybe they're not beautiful code, but you can at least use them, right? And then, like lastly, it's a pervasive problem for us because we want to have this information, and a lot of the other software like ecosystem, the whole world, the industry of software is like, who cares about that? We need to move faster. And we say, well, we want to care about that. Doesn't mean we have to move slower. I don't know, maybe. But it's like the fundamental problem of our model, I would say. You've gotten to the heart of it. So not a lot of good advice. There are things you can do, but it's a difficult problem.
So just pain and sweat.
Pain and sweat gets you far. You know, I've used that technique in the past.
As much a cultural problem as a technical one.
Yeah. That's true, and that's what I meant when if you don't worry about upstreaming, you can just automatically bring in all of those. You can do a much better job through code. You don't have to worry. You know, you can say I don't even care about the licenses. You know, no one's going to sue me. I can get whatever. Like you can decide these things for yourself. The Geeks project won't like that because we have strong. You can start a channel that aggregates this work. Like I think more people should start channels that have less strict requirements. That's what Geeks needs at the moment, I think. Yeah, but thanks for the question.
214.
I have one more question, if you don't mind.
Yeah, I'll come talk to you if you like. I think there might be someone else giving a talk, so I don't want to be here.
Just about to be in room.
So these programs are just general purpose packages. Package scripts are just general purpose scheme programs, and they run make files for the building. But they're also supposed to be pure in that they input and output. If those scripts or the process pulls files,
The signs on the doors say that the room numbers in the book are not right. So this is room 3 at least today. I'm not sure about tomorrow, but it's attached today and tomorrow.
I'm glad I'm not alone.
Do you want to say hi or an audible tone though? Because if you have a Geeks profile that says that a certain package and package itself is on version 10, and that package produces different hashes, different binaries every time you run it, so the version's not changing. Isn't that kind of a problem?
Yes.
I don't think it would be unreasonable to, first of all, Geeks pervasively repackages things from like PyPy or Cargo, for instance, and you show it how to patch build scripts. I don't think it would be unreasonable to take the line of code that downloads from the internet and patch it with a G expression reference, referencing an origin, which would contain the hash expected from online.
Yeah.
You still have to update that.
on the web and this thing.
Yes, the room is wrong, I think. This is room 3 for real. What? I'm not in room 2?
Or just like you said,
I'm not in room 2? No, room 2 is room 238.
But
That's not what the book says, but the signs on the door tell you that what's in the book.
does say room 2.
What's this lecture? Yeah.
Well, and this lecture was actually scheduled to be in room 3. That's why you're saying that, right?
Well, we showed up in room 3 and then got room 3, 238 and got sent here early. So that's all I really. Okay, so what's this gonna be?
Well, I think it's going to be the 50 years ago.
Okay, that's what I was coming
But that's why I brought it up.
Sure.
Yeah, I think maybe just sit and wait until the speaker shows up, and if no one does, walk to another room.
You can choose not to use
It would make sense. The other room is quite small. so I would be surprised if it was
program the build
longer, bigger tokens, but.
and all the dependencies.
And then this one is actually, in here, was supposed to be a half hour early.
Oh, okay.
See this,
Oh, yeah, for sure. Schedule's a little
GNU+,
weird. Yeah.
was supposed to be at 12. Unless I'm reading this.
No, it was supposed to be at 11.
Yeah, I think the times are just weird too. It's 10:30 and 11 today, sort of run together.
So you guys are here for floss, right?
No, well,
We're not sure. We're having a discussion about it.
Yeah.
Oh, okay. The schedule's wrong, but we're not sure how wrong and in what way.
Everybody's so confused.
So we're just meeting
So this
here,
is
comparing notes.
supposed to be
But,
room 2.
But is room 3 is listing on the schedule?
Yeah, as far as I know.
I know, that's what, yeah.
There's room 3 on there, that's what I'm hoping.
Yeah,
Okay. Well, no, come on.
Now, I think we're gonna.
It's true.
I thought this was for 2.
Now it's room 3.
Oh.
It's officially room 3 now, because room 2 is swapped. That was the least confusing thing.
Okay.
Where the talk is at, because one of the talks canceled.
Yeah.
This is the bird one, I believe.
Sure enough, it's canceled.
Yeah.
Okay, so we're confused between what's on the.
Yeah, I'm sorry. It's they're due to technical issues. We had to switch the talk or the room numbers.
Is this what you're looking for?
Hello.
Okay, I was like, yeah. So this is the bird.
The what?
All right, birds are happening here.
Yes.
thank you.
Are you? Yes. I'm signing in right now. Or well, so. Hang on. Yeah. Give me 1 second, and we'll sort it out. Okay. Thanks.
And then like once things start like veering to the left, that makes sense. Like once things like start. Oh yeah, for the
It's not on this floor?
No, it's on this floor. It's just like straight.
Oh boy. Are
you doing Linux like it was 50 years ago in here?
I just got a call from the speaker. The links didn't get swapped.
Yeah.
Tell them to use the other one.
Tell them.
Do they have the other one?
I don't know if he has the other
Shit.
one.
Okay.
Everyone in the other room though is upset because
Yeah.
they wanted to watch the other talk.
Let me switch the links. Tell the speaker.
All right.
And yeah.
And these are like 4 or 5 different programs. That's basically like, I don't know, easy ones are like 5
Thank you.
hours to get one package.
All right.
Or package all of its dependencies and everything. And some of them are so big that I haven't even been able to finish. It's an ongoing process. The other.
Do you live in Vermont? Where will you see birds at?
Well, in Oregon. Yeah. So, I don't know why, but
I don't do a lot of birding, but I used to get to learn about there's a big bird sanctuary. And there's lots of operations.
Oh, that's cool. I'm from Texas, but my hometown where my parents live is a real rural little place on the Gulf, and so the only thing is there's like this nature. It's like a small little college community, but they have this marsh and a trail that like the state paid for because there were so many bird species there, and I was like, oh. That would give me a great reason to go visit my parents more, is to go like, oh, I'll go check out the birds. Yeah. You know, so, or I could get them into it, you know, maybe because they retired, they've been going camping, and they've been going to all the state parks, and they're running out of state parks. So now, I think I'm gonna. It's like, oh, okay, well, here, do some birding, go travel the country, you know.
So, it sounds like you've done a lot of birding.
Well, I've looked at a lot. I've gone and looked at birds, and I have like the guidebook, you know, with all the different.
What's going on 50 years ago?
I've never done anything with it. I just go around.
I'm working.
You know, I just go
Okay.
check them out.
I told the other guy that he's in the wrong room and to go back to the link in the email. Is the link in his email updated? One of them is. I don't know which.
I wish I.
Okay.
I think the big thing is finding
Track 3. Okay, track 3 needs to be adjusted.
Like, one of my buddies is digging in finding mushrooms and stuff, and it's like.
Did we rename the
"Why did
StreamYard
you
rooms?
Super into that.
Yes, I renamed the StreamYard rooms.
Okay, so that should be. What are you trying to? Then you end up in subgroups. But what are you trying to do? Okay.
And then this needs to go up there. So I need HDMI for this laptop.
Alright, two. Okay, links should be updated.
Okay. Yep. Where is that window? Hey, there it is. Okay. Yep. This is, why is it subtractive manufacturing?
Hey, so sorry for the delay. Can you click on the link that you got in your email again?
Okay, I believe I'm back in the show. So can you hear me now, people of the world? I wonder. It doesn't look like you can see me anymore, which is strange, because you should be able to. I don't know why that's not working, but can you hear me? I will wait. Yes, we can hear you. Excellent. I'm now in the right room for real. So sorry. No problem. It's all good. Hello, everyone. Okay, welcome to Using Floss to Plan Your Daily Exercise by Birding with Richard Littauer. This is going to be an abbreviated talk, but I still got some time. So kind of an interesting talk in that, you don't need to use birding to bird, but you can. So who is this? Well, this is me. I'm the guy in blue, not the other people. I'm a linguist. I'm a Latin tutor. I used to know the Na'vi language. That's why I'm dressed like a Na'vi from the movie Avatar, but developer of I'm saying what is open source software, which is why I'm at this conference. But also I'm this guy. I'm a birder. I'm a Washington County, Vermont birder. That's where my home is when I'm there. Right now I'm in Costa Rica, which is just lovely. I've been birding here for the past week, and it's been very, very intense. Highly suggest if you ever want to see more birds. Wow, a lot of birds. I'm an unaffiliated ornithological academic, meaning I write papers for fun. I'm an eBird reviewer for some islands in the South Atlantic and Addison County, Vermont. Used to be on the Nature Center. My local Nature Center was on the board. I'm a sometime bird guide every now and then, and I contribute to INAT. So I do a lot of things involving birding, not just one or two things, but like too many things, which is kind of fun. That's my dad. What is birding? Is a good question. So if you just look at birds, is that birding? Kind of, yeah, but generally birding is looking at things and trying to describe what they are. So saying, oh, I know what that bird is. It's this bird. And if you're really into it, you could also say, I know what that bird is. I've seen it before. I have a list of birds I've seen. That's the main difference between, say, looking at birds and bird watching. And then birding or a birder is often kind of the autistic completionist version of that, which is saying, I want to see all the birds, collect all the Pokemon, etc., etc. I mentioned eBird before. What's eBird? Well, it's a website where you put lists of birds that you've identified. Super simple, but it's massive, right? There's 10,000 species in the world. They're all pretty much represented on eBird. But 85 million checklists from people, that's a lot of people. Almost 1 million people have been birding. I'm just going to run on over, by the way. I see a seagull. Feel free to comment, post here in the elements if you're watching this, and I can just check every now and then and see if any of those come through. So, eBird is pretty awesome. It's a website. It's run by Cornell. I really like it. Now, you may be asking yourself, that's cool. Why would I want to put lists of birds anywhere? Like, who cares? And well, the answer is that birding is kind of an interesting act. It's something you could do like jogging or walking or playing canasta. But it has all these extra things that are useful. So one has proven health benefits. Studies have shown that if you like go outside and hear birds, your stress levels go down. It's like amazing. It's like having a fish tank in your room or a Japanese peace lily. Really useful. Sometimes birding can mean exercise because you have to go walk to the birds. That's pretty sweet. Sometimes you can go hiking. It means you get out more, right? Also, birding tends to, people tend to bird together. And so you get more ties to your local community when you bird. You get to know who's who. What's really great about this is the intergenerational ties. A lot of birders are older. Some of them are really young. And so you get to meet people from all ages because it's not an age-specific sport. You also get to understand the passing of time differently, what seasons come and go, especially in the northern hemisphere. We get to see migrants come through, you know? So when spring, it's not just spring, oh, nice, soon it'll be summer. It's spring. This is the cool season. And of course, you get the sweet, sweet dopamine hits of like seeing new birds. Every time you see a new bird you haven't seen before, your brain literally floods itself with endorphins. We were evolutionarily evolved to like go hunting. Birding is like hunting, you just don't kill the thing. It's amazing. And if you really like seeing a bird, you can always treat yourself with cake. Cake is the best. So that's pretty sweet. Do you have to list birds? No, you really don't. Don't bother if you don't want. You don't have to name every bird. You don't have to do everything in the world. But it's useful, right? If you do. One, listing birds help you identify what's not on the list. It helps you learn more about the place, helps you improve your own knowledge of things, which also increases the dopamine hits. Helps science. We have better understanding of birds because of eBird, because of tools like eBird. And also listing can lead to gamification. Gamification is like a brain hack where basically you end up with awesome dopamine hits, right? And who doesn't want those? This isn't even bad dopamine. It's not like sugar, which, makes you crash later. It's just sweet. So I think listing is pretty awesome. It's a conscious choice. If you want to start doing this, you can just start doing it. You don't have to feel it first and then do it. Just try listing for a while, and then eventually the dopamine will come. I swear. So that's cool. And gamifying birding? Yes, definitely a thing. Here are my stats as of yesterday for eBird. And man, I love watching the stats. I love streaking. Look at the days of checklist streak. I've been birding way too much for too many days. And there's joy in my voice right now, in glee, because it's been gamified for me. My brain has trained itself to think that this is important in life. Doesn't have to be important for you, but hey, man, it is for me, and that's cool. That's cool. I'm also not showing this to show you, like, look how cool I am. I've seen so many birds. That's it. No one really loses if you see less birds. It's just, this is what I've been doing for a while. How nice. You could do the same too. Why not? It's pretty sweet. eBird allows you to see what other people have posted, which is really cool. And also lets you decide to see like where the best places are in your region to go birding, which I really like. So there's a list of like the top eBirders in Washington County. I've been trying really hard to get to the top, but Chip keeps sitting up there. He's been there longer than I have. That's cool. That's cool. And top hotspots. It's cool to see that Berlin Pond is like the best place to bird. But you know, Blanchard Park isn't that bad either. Blueberry Lake is pretty good, right? This is cool. And it's fun to see like how many birds can you get? Can you get more than that person? And again, no one loses. There's no sidelines for birding. So that's kind of fun. This is Blanchard Park. It's the park behind my house. And I've been spending a lot of fun trying to gamify whether I can add more species to the park or like to my yard, as it were. So that's been really cool. You can see I've added a lot of checklists there because I just like birding in that spot. And it's fun to gamify to see whether I can see more. You can also see when you look at eBird, you can see this cool list of like photos from that area, audio from that area. And the dark blue is birds that have been noticed seasonally, right? In those weeks. There's actually around 50 of these dark blue things. And for each week of the year where it's been shown, you can see how many have been shown. That's awesome. So maybe like, November, no one's ever seen a mourning dove. Maybe that'll get me out of bed. I want to go see a mourning dove so I can make this blue. What a cool idea. You can look at other hotspots. This is Harrison Preserve. It's a reserve across town from me that I only recently added as a hotspot on eBird. And you can see the white areas, like in July and June, there's a lot of white there. That means no one has birded at Harrison Preserve during those months, during those weeks. That's cool because it means, oh man, I should go bird there. I should go bird there. Right? Looks like November, December, it's going to be some great opportunities to go see birds that no one has ever seen in that place. Right? Why not? Let's fill it out. Now, this is where it starts getting technical. I made this website, birdinginvermont.com, where I build tools, and it's open source and it's online. You can access it, at birdinginvermont.com, on my GitHub, on Richard Litt. I'm just going to share that in the Element chat for y'all. Which is cool. It's a React D3 site, mainly. It's kind of fun. And I built these awesome extensions, which is fun. So I built eBird extension, which is here for those of you who want to see it. And basically these are tools for like working with eBird's API and for dealing with all the massive data that we can get from that to understand where birds are and what we want to do with them. That's really fun. So one of the things I wanted to do was I wanted to have a script that would tell me if a hotspot has been birded on a given week of the year, right? Remember this bar chart here, whether it's white or blue or really blue for those birds. And so I also wanted to know whether a hotspot had ever been birded on any date of the year. So I could know like, oh, it's never been birded on Christmas. Let's go bird it. Let's go have a nice little Christmas afternoon. And I wanted to know that for hotspots an area from my house. Why not? So I built a script, and what it does is it downloads all the data from eBird. It's what you first have to do manually, and then I shim that to JSON. That's like an ugly process, but it works out. And I just did this for the state of Arizona for the years of 2022 and 2023. That was 4.5 gigs of CSVs, just CSVs files. It's just massive amounts of data, like millions and millions of rows. Super cool. So you shim that to JSON, and then you filter it to only get the hotspots or locations near you where you want. You can also do this for your yard list, which is cool. So you don't have to it doesn't have to be like a public location like a hotspot. It can be any location that's used on eBird. And then I filtered for that data, and then I made an array of weeks and dates for those hotspots have been birded. And so then I have this little bash script here, which basically runs Node, and it runs it on Montpelier.js, which is the file I use to show hotspots in my area, because that's where I live. And it puts that into a log. And then I use Python to email that log to me. And I have this little script running on a cron job. So every day at 6 a.m., it runs this script, which is cool. You can see that there. It's at scripts. Let me just share that here. You're welcome, MNW. You're awesome. And I get this email every morning, right? I got one today at 6 a.m., even though I'm in Costa Rica. Why not? And it also goes to my friend Rebecca. Rebecca, you're the best. Hi. And it says, hey, today, the last time Confluence Park was birded was on October 9th. So that's been like 3 weeks. 54% of the weeks at that park have been birded. And here's a link to the hotspot. And so what this does is it tells me which parks I should go to in my area. Now, these are the parks the hot spots in my town. Montpelier actually has like 11 parks. It's pretty amazing. It's a small capital. It's only like 7,000 people, but it's the capital of Vermont. And I've added each and every little tiny pocket park, some of the bigger parks as well, on eBird. So what this does is it helps me figure out which park I should walk to in the morning, because I'm going to go there and I'm going to count the goldfinches and count the crows. Why? Maybe it'll be something different. Maybe your Jill Falcon will show up. That'd be so cool. Maybe seagulls. So why not just go and look? And this way, every morning when I go for a morning walk, I get exercise because I've gamified that birding is something I like doing. And birding locally is something I like doing. And birding at local parks is great. So that's really cool. And you can see more top hotspots on eBird. You can look for other stuff. But then the answer is like, okay, dude, you made this script. This sounds like a lot of work. Does it help? Yes. Helps me get more exercise. It helps the science of us understanding what birds are coming through Montpelier. And actually, urban places are underbirded in the data, because most people who bird go to really cool places, and they're less likely to go to small parks downtown. So it's actually really useful for science. I get to have more fun local birding. I get to have a lot of croissants, and I get to have knowledge of local parks. Now, finally, this also informs local policy. When the city was looking to change the composition of the park behind my house, Blanchard Park, I was able to give them a massive histogram of data, bird data for the past 5 years. They're like, we don't really know what birds are here. And I'm like, excuse me, raise my hand. I've been birding this park every day for years. Here's what birds are here. And they're like, oh, it's really useful. And it was. And in the PDF that the city made, they had my histograms at the end of the PDF report. It's awesome. So birding locally can help you preserve local areas and show the importance of that, not just for you and humans, but also for nature. Super fun. So now the question may be, well, how do you do that? Well, I would love to help you do that. It'd be really cool. As you notice, I already emailed this to Bex Waterman, my friend, and I'm happy to do the same for you. If you're interested in birding locally, if you wanted to get a little email saying, hey, where do I see birds? And how can I see birds? Not going to get exercise. That's cool. But also, I'm really happy to just chat about birds. If you have birds in your yard or around that you want to see, just hit me up. I'm like available. Richard.social is all of my socials. That's actually a URL. I bought that one, so feel free to use that. Richard.social. You can also hit me up on WhatsApp, which is here, or Signal, whenever. And since this is SeaGL, I really wanted to mention what SeaGL is the SeaGL logo? It's a very good question. And I looked through all the seagulls that are available in Seattle, and it turns out only one of them has a yellow bill without what's called a gonadal spot, which is a red spot at the end of the bill that young birds peck at to tell their parents that they want to be fed, and which then causes an involuntary regurgitation response, meaning they throw up by the parents into the young's mouths. But this bird doesn't have it. This is a short-billed gull. It's a new gull. It was only split out from the Mew or common gull like last year, and it's in Seattle. So when anyone ever asks you what seagull is in the SeaGL logo, I would say short-billed gull. Super cool bird. Love this bird. And I think that's the end of my talk. I hope you've enjoyed it. I haven't heard any laughter or signs because I haven't heard anything because I'm doing this remotely. Again, I'm in Costa Rica. Sorry. But hope you have in mind the hotel lobby stuff, and I'm totally available for questions. Thank you so much. Woohoo! Super fun. I've got 9 new life birds today. Yeah, it's really cool. It's also really cool that you can use code to do birding. I really like doing that. I don't just do it for my local walks. I do it for things like helping other people sort through their data to see what they should submit to the records committees. I like showing people what birds have been birded in what town. That's really fun. Thank you, Bree. Thank you, Bree. That's really cool. Applause. That's great. Much applause. Wow. That's exciting. It's a bit much. Yeah, other, I don't know. I just really like messing with bird data. I've recently started doing stuff in R and the like. As an eBird reviewer, it's my job to actually go through all of the records that are submitted in the 3 islands in South Atlantic I mentioned, Ascension, St. Helena, and Tristan da Cunha, and also Addison County, Vermont, which means that anyone who submits any record there that's weird, I'm the person who goes through and looks at it. And so I'm using code now to inform my tools to make eBird a better database too, which is another use of code. Maybe I'll do that next year. But yeah, any questions, anyone? No questions? Just applause? That's also cool. Sorry for talking very fast. I'm sorry I'm not there. If it helps, I was in a cloud forest this morning. I felt like I was in Seattle. It was raining. No? Okay. Well, in that case, I'm going to let you all go. Thank you all so much for coming to my chat. Oh, Bree is typing. Bree is typing. Thank you for letting me attend. It's really cool. I wish I had more time to attend for the rest of the conference. Unfortunately, I really have a very intense birding guide and plan for the next few days. So this is my talk this year, and I look forward to looking at the talks from later on and watching the streams. So I'm looking forward to that. So thank you all so much. Thank you, Salt, for inviting me. Thank you, Deb, for giving a sweet, really awesome opening keynote. And with that, I'm going to stop sharing. So have a good day, and seriously, message me about birds. I like birds. I'm happy to help you like birds too.
that work? Hey, that works. Great. Wonderful. So, you are streaming and recording, and that's live. Thank you.
All right. I got it. Okay. Phenomenal. So I'm going to go quickly because, oh geez. All right. We're 5 minutes into the talk. Hey, everyone. I'm AJ, and this is Pulling Back the Curtain with SeaGL Tech. You have already seen a little bit behind the curtain because, like, you know, I got in here and it's like, oh God, my laptop doesn't connect with HDMI and OBS isn't set up and all that jazz. But here we are. Hopefully we're live on the internet. A little bit about me. I was born in Seattle, but I live in New York City now. Pronouns they or he are both fine. I run Firefox and Emacs and Fedora Silverblue. It's a good time. I like tinkering with things. I like self-hosting things. I work at a company called January, which is in the consumer credit space and like the consumer finance space. I've been coming to SeaGL for about 10 years, minus a couple years in the middle. And for 2 years, I have been the co-chair of the SeaGL Tech Committee. So I just kind of want to give you a little peek as to how we run the conference, how things work behind the scenes, that kind of thing. So what does the Tech Committee actually do? We're responsible for a bunch of different things. We are responsible for the virtual conference experience. So especially since the pandemic, this has become a big thing that we do. We run the Matrix space, the Jitsi rooms that are used for the social rooms. And new this year, we're running all the live streaming and all of the AV stuff on site, which, as you may or may not have seen, has been a little bit of an adventure, but hopefully we've fixed a lot of those issues now. We also run the year-round infrastructure of the conference. So a lot of that means writing new stuff, new software. Sometimes it means taking existing software and deploying that for us to use. And mostly it just means maintaining a lot of stuff, maintaining existing software, maintaining infrastructure, that kind of thing. And we're also responsible for the website, seagull.org, and we're responsible for a lot of sort of miscellaneous things that, you know, just kind of come along with the above. So in a lot of ways, this talk is really just a love letter to the open source and free software community. We really couldn't do it without them. It just would be an impossible task to put on this conference without all of the awesome work that the community does. So I want to talk a little bit about time. This is on the tech committee and really in the conference in general. This is by far our biggest constraint. And there's two kinds of time that are a problem for us. One is volunteer time. So SeaGL is all volunteer. And so that means that we all do it in our free time, and everyone has jobs and families and other things that they do, hobbies, like time to touch grass, that kind of thing. And so our volunteer time is very limited. And the other thing that we have to deal with is time before the conference. There is only 12 months before the conference, which sounds like a lot of time, but really is not, especially because we are all exhausted after the conference and don't even want to think about it for a couple months after November. And so having to operate on a strict timeline where, like, all right, we got to get all this stuff done by November 3rd, or we got to get all this work done on the website so that we are able to open the call for papers to fill, you know, the amazing program that we have here this weekend. All that is something that's always present for us. So because of that, I spend a lot of time thinking about sustainability. And I don't mean sustainability in sort of the environmental sense. I mean sustainability in the sort of dictionary sense. How can we sustain what we're doing over time? How can we, like, not get burnt out, keep getting the conference to work, that kind of thing? How can we take advantage of mini economies of scale, or to put it a way that I think a lot of free software people would find familiar, how can we take advantage of the free software community and stand on the shoulders of giants? And how can we help the rest of the conference do the same thing? We're not the only ones with the time problem, so how can we help other people in other committees on the conference make the most effective use of their time. So just to talk a little bit about this in more detail, I want to do a little bit of a case study on Awesome. So Awesome is our conference management software. You may have seen it when you looked at the schedule. It's also what we use to manage our call for presentations. Around December 2021, which is when I became the co-chair for SeaGL, Awesome was not in a great shape at all. It was sort of famously among the organizing team and among Awesome Upstream about 8 years out of date with Upstream. Super janky. We had a bunch of custom patches that were like, that was the reason we were out of date. Awesome was manually deployed to an Amazon EC2 machine, and nobody really knew how that worked. So even if we had a new version, we were like, how can we even deploy the thing? Generally, it just was not in a good shape. And so we ended up deciding on, we ended up going with, in order to fix this problem, we ended up going with a piece of software called Doku, which has been really a bit of a game changer for us and super helpful. So if you aren't familiar with Doku, a sort of easy way to explain it is it's open source Heroku that runs on a single host. So what that means in more detail is it means that you can just push some code to it, and Doku will just do the right thing. It will install your dependencies for you. It will run all your build scripts. It'll compile all that into an app bundle, and it will deploy it for you. It will help you monitor that app bundle. You can scale your application, at least on one machine. You can do more, but we don't because we just don't need to. And it will even do really neat tricks, like it will help you deploy new versions of your application with zero downtime, and it will go manage your HTTPS certificates for you, that kind of thing. It's so awesome. And the reason that this has been so awesome for us is it's allowed us to separate the service that we provide from the capability. Okay, sorry. Doku gives us a deployment capability that we can maintain only once and then reuse in the future instead of doing the same work over and over again. So now, because we have Doku, we are able to run Patch, which is the bot that manages all the matrix spaces and a lot of aspects of the virtual conference. We're able to maintain various other sort of matrix utility things. Malbot RSS is a piece of software that basically takes an RSS feed and pipes it into matrix, which is super helpful to us for a number of reasons. Malleus proxy does a bit of magic with matrix in order to give us pretty SeaGL.org room names for all of the rooms in the conference. Mjolnir is a matrix bot that we use to moderate the conference space. So this is how we deal with spam and harassment in the virtual conference, if those were to come up. And we run Awesome, our original problem, on Doku, and it's been really awesome to, no pun intended, to have that just work and just be managed for us. And we can maintain Doku once and have that work across all of these programs. There we go. And soon we want to put even more stuff on Doku. We need a password manager. Currently we're on 1Password Teams, and it works okay, but it's not great because it's not free software, and all of us would love for it to be free software. So we're going to deploy Vault Warden, which is an open source reimplementation of the Bitwarden API. And we want to maybe eventually bring the IRC to Matrix Bridge back. A lot of people have asked us about this, and our answer has basically been like, hey, we would love to do it. We just don't have enough time. So hopefully at some point we will be able to bring that back on Doku. And if anyone is interested in stepping up to do that, I can give you lots of pointers as to where to go. Help us do that. And we manage all of Doku through a tool called Ansible. So Ansible is a configuration management tool that basically means that it helps you manage the state of production servers. And in particular, the way that you define that state is in text files that can be version controlled. So that means that we can use all of the existing workflows around version control, like pull requests and reviews and that kind of thing in order to help manage our production servers. And that's really awesome to have because it lets us automatically deploy to production on merge. So when we merge a pull request in GitHub, GitHub Actions will kick off and we'll automatically go reconfigure our production servers with the new Ansible. And that means that A, that's a bunch of manual work that we don't have to do anymore and are not as likely to make mistakes doing. And B, that means it's accessible. That means that as the co-chair, I don't have to hand out root access to everyone who wants to contribute to our infrastructure. I can just tell them, hey, go clone this Ansible repo, and you're off to the races. And they can pull request, and I can merge it, and that will end up in production, even though they don't have direct access to that machine. Because I know that someone's going to go looking. Our Ansible is not currently public. We want to make it public. It's just it has some secrets in it. So that's why it's not public, but it's on our roadmap. Another thing that's been really helpful to us in running the conference is the Open Source Lab, which is part of Oregon State University. They are, first and foremost, wonderful people. They've been so awesome to work with. And they provide basically just common infrastructure for open source projects. So they'll do things like run Mailman to manage mailing lists for you. They can give you access to virtual machine capacity, high performance MySQL databases that they'll just like manage for you so you don't have to think about it. I like to think of them a little bit as like Software Freedom Conservancy for infrastructure. If you're not familiar with Conservancy, they provide a bunch of umbrella services for open source projects. So they'll do things like hold your trademarks for you and help you take donations, I think, and that kind of thing. So Software Freedom Conservancy is also really wonderful. And OSU OSL, I think I don't speak for them, but they, in my mind, have the same approach to sustainability that we do. So, for example, we asked them to set up Nextcloud for us. Nextcloud is a super awesome piece of free and open source software. Here's a screenshot of the homepage of Nextcloud. Here's my files view of like all of the sort of committee folders we have to manage the conference. Nextcloud is really important for us because currently we manage a decent amount of the conference on Google for Work, which no one has ever really been super happy with because it's proprietary. But now we are especially not happy with it because it costs money, because Google killed their free tier. So we would really like to get off it, and Nextcloud is a great path to doing that. We already have basically gotten rid of Google Calendar using Nextcloud. We're kind of deprecating Google Drive because of Nextcloud. So that's been really awesome. You may have noticed our transition to Nextcloud because now on SeaGL.org, there are no longer any links to Google Forms anymore. We just use Nextcloud Forms everywhere. And it's been awesome. We used Nextcloud as the method that speakers submitted their pre-recorded presentations this year, which has been really convenient for everyone because we can have it just synced directly onto the laptops. And because of the way that OSU OSL set this up, now it's available for any other open source lab project too, because they did it also in a configuration management tool, just one different from ours called Chef. So even in this original issue about where we requested, hey, can we get a Nextcloud? Whoops. All right, I probably should have uninstalled my Cloud to Bud extension before I took this screenshot. That's okay. What are you gonna do? Anyway, even in this screenshot, you can see in the checklist, there's a note that like, hey, our priority is we want this to be available for other projects that we help too. I mentioned earlier that OSU OSL gives us VMs. They do that with OpenStack. So here's a screenshot of our OpenStack instance. You can see some virtual machines listed here. OpenStack is basically common open source cloud infrastructure. You can think of it as a little bit like an open source version of AWS, but kind of bare bones. And this, like Nextcloud, has provided us a path off of proprietary software. We are going to use this to mostly get off AWS, if not entirely. And it's been incredibly helpful because it lets us spin up our own virtual machines that we can just do whatever we want to and need with it. So we've used this to run the 2022 and 2023 temporary conference accounts that people use to attend the virtual conference anonymously. Soon we'll be using it to run an open source mail stack called MailU, which is going to let us get off Gmail. And we would like to migrate Doku over to OpenStack as well. So that's currently running on AWS. But now that we have OpenStack, we're going to be migrating that. So that's been really awesome and has let us just not worry about any of this stuff. I'm running a little low on time because of the AV shenanigans, so I'm not going to really go into this, but this is a lot of other stuff that we use. For example, Element is used in the Attend portal. Internet Archive are really great people there, where we put our video archive. And in particular, I want to call out Sentry. They have like the best open source plan ever. I emailed them and I was like, hey, can we get like a pro plan for your open source thing? And they emailed back in, I'm talking like half an hour. And they were like, here's your business plan. So that's been incredibly helpful to have because, I'm sorry, I should have mentioned, Sentry is an error tracking service in case you're not familiar. So while we were, for example, transitioning Awesome from that super unmaintained old janky version to the new upgraded version, Sentry was really helpful in determining, hey, is this completely broken? Like, are users experiencing problems? And so we could actually make that transition with some amount of confidence, which is really helpful. And I also want to shout out Seattle Matrix. Seattle Matrix is a local group of people who maintain some shared infrastructure just for anyone to use. So they maintain a Jitsi, which we use to meet during the year. They maintain an Etherpad, which we use to take collaborative real-time notes during conference meetings, conference plannings meetings. And they run a Matrix home server. And their Matrix home server is actually what the entire conference event space is running on. It doesn't run on our own Matrix server because that gets torn down a week after the conference. So Seattle Matrix has been a really great partner for us, and we're really grateful to them. There's lots of stuff that I would love to do if I had more time. For example, our audio-video stack is not fully free right now. I would love for it to be. People have asked us a lot, hey, are you going to stream on PeerTube? And I tell them, we would love to if someone steps up and makes that happen. And we'd love to do, for example, some improvements to Awesome to make things easier for the program committee. Dawn Cooper is the chair of the program committee this year and has done some really heroic work to make this conference actually happen. So shout out to her. I would love to make her life easier. And if you want to make her life easier, you should consider volunteering for the program committee. One other thing that I would have loved to do, you may have noticed that I'm using a generic template that I picked when I opened LibreOffice Impress. The reason being that I was busy running the conference, so I just literally didn't have time to make a presentation template. I would love for someone to volunteer for a bunch of stuff so I could go make a presentation template and not use a generic LibreOffice thing. That would be super awesome. So yeah, we would love to have more volunteers because there's always more stuff to do. And finally, just to make sure I end on time, I want to give some thank yous. Thank you to Seattle Matrix. I've already mentioned we really rely on them to run the conference. Thank you to the Open Source Lab. They've been just, a game changer, so helpful. And we also really couldn't do it without them. Having a path off Google is so phenomenal, and it's free too, free in every sense of the word. So they've been wonderful to work with. Thanks to the entire SeaGL staff, and in particular the tech team. Even more particularly, I want to shout out Andrew on the tech team has done an incredible amount of work in the last 2 years on the software side of things. He is basically single-handedly responsible for getting us off a 8-year-old version of Awesome onto something more modern and in sync with upstream. And I also want to shout out Romeo, who has done just like an unbelievable amount of work and running around and being in the trenches with me to make sure that we actually are able to live stream this year and that the conference actually happens. I would have fallen apart long ago without him. And as I've kind of been alluding to, I meant to advance the slides before I said all that. That's okay. The point that I was trying to make is that the SeaGL organizing committee is it's made up of people who are in the community and just want to make it happen. So thanks to everyone, but also to all the individual people in there. And I also want to shout out my work, January, because I know a lot of you are watching. Frankly, a lot of them have listened to me just complain / be anxious about this conference for 6 months. And then in the last 3 weeks have listened to / watch me have a slow meltdown in trying to make this thing come together. So thank you all for your support. I really appreciate it. And by the way, January is made up of people too. Some of the best people I've ever had the pleasure to work with. So if you are interested in that, we are hiring. And with that, here are my socials. Slides, well, this says slides are available. They are not. They will be available on my website at strategy.net/talks. Here are socials for me and socials for SeaGL. And with that, come volunteer for SeaGL. If there are any questions, I would love to take those. And I'll actually go back to this slide because that seems more useful.
Yeah, I have a question about where do you host your VMs?
Yeah, so the question was, where do we host our VMs if we're getting off AWS? So we host them now in OpenStack with OSU OSL. So they basically run an OpenStack for us. They have like I don't know exactly what their hardware setup looks like, but essentially they have like a bunch of different machines that they physically run all this stuff on. And so that's where OpenStack is running. And we basically just get an OpenStack login and can go provision that ourselves. That also, by the way, is all in version control. Well, sort of. It is somewhat actually and definitely very aspirationally in version control. We use a tool called Terraform to manage that. So you can literally like submit a pull request to our Terraform repository, which is actually public. And then on merge, that will go create a new VM in OpenStack. Did that answer your question? Phenomenal. I'm just gonna check Matrix real quick. Yeah. Any other questions? Cool. All right. We ended 2 minutes early. Thank God. Thank you all very much for coming. Yeah, the battery's super low. Yeah.
Okay, scene collection.
Let's check. Any other questions? Cool.
All right.
We're 2 minutes early. Right now. Thank you all very much for coming. Yeah.
Am I live right now already? Okay, thank you. So first of all, thank you very much for having me. I am super excited and nervous about it, and my imposter syndrome has been as strong as it can be for the last few weeks since I knew that I was going to present with you guys and girls and people. So this talk is going to be about the creation of a hackerspace in Mexico in the city of Querétaro, which has been an ongoing project for a number of years in a number of ways. So this is a picture of a kind of a messy angle. I'm going to show you at the end of the presentation where I'm sitting right now. As you can see, there's a propaganda wall right behind me, which is the first thing anyone sees when they come into this space. Now, this inevitably will be about my own personal journey. So I tried to make this a little bit more generally interesting information. And so I'm going to talk about that in a second, but just please bear with me. So first of all, why? Why is it important to build a hackerspace? Why did I want to have a hackerspace or a hack space, which is another topic that is important to address, and we will later. Why is it? First of all, because you want to have more friends who understand what you're talking about. I found myself so many times in social situations where, you know, I just want to talk about the progress of AI, but people look at me funny. So it's always good to have a space where you know there will be more people who really understand you on levels that most people don't. Secondly, very importantly, you want more space for your home lab, but without sleeping to the hum of a server. Or maybe you don't mind sleeping to the hum of a server, but your significant other really doesn't want to, or doesn't want to hear the little motors of the 3D printer as, you know, you're making yourself a new brake handle for your bike at night. Third reason, you realize that you can't possibly have all the gear you want by yourself, but you also don't need to have it all because you're not going to use it all the time, right? Wouldn't it be better if you could share your stuff with somebody else and somebody else could share their stuff with you? So that's a big point here. And well, last but not least, the world is slowly creeping towards a full-on techno-dystopian future, and only those of us who know how to self-host federated services can make a difference. I think that's an important reason, and it's directly tied into the kind of hack space that we are trying to be, right? We are trying to promote free software above all, and to use it above all, even when sometimes you know how it is. It doesn't necessarily always work perfectly. But when it does work, it's amazing. Either or all of those. In addition, hacking, the hacking scene in the broad sense, at least over here in Mexico, and surprisingly so, because, you know, we have a huge country, we're right next to the US, we have all sorts of industries sprawling all over the country, and yet these sort of spaces are really unique. South America has a more I would say, a more prominent free software and maybe even, well, hacking scene. So in that sense, we can look at this map of registered Mastodon instances. Obviously, if you don't say any country, right, if you don't state where your instance is, it's just not going to show up, or it actually shows up at the South Pole. But nevertheless, you can see that there are none in Mexico, right? Maybe one of those, if you zoom in, are going to be here, but in general, it's not a very common thing. Same thing with the hackerspaces registered on hackerspaces.org. So you can see the number 6 here if you squint, I guess. Of those 6 spaces registered there, we have contact with another 2, which are Rancho Electrónico in Mexico City and Hacker Garage in Guadalajara, which I'm going to mention a little more further. The other 4 there are a space controlled fully by the government in Mexico City, which is basically like a fab lab. And there's a hackerspace in Monterrey, which has its own website and always elusive WhatsApp group, which I haven't had access to. And I haven't had any contact with them either, even though, trust me, that I've tried. And another place is the Inventor's House, which is registered there. Actually, I lied about the government-controlled one. That was, I saw one on the Fab Labs page. The one here, the second one in Mexico City that is not Rancho Electrónico, is now like a company that creates maker and hacker spaces. So you can hire them for that, but they're not really a hacker space, right? And Inventor's House in Aguascalientes is basically also a company, right? So it's not a hacker space anymore, at least. However, yeah, well, I'm gonna give a shout out to them later, the Electronic Cats. So we ran a census for a month. These are the main quantifiable results from it, right? We sent it to about 2,000 people from different Telegram groups, encompassing both the general Latin American hacker scene, or self-appointed hacker scene, as well as some groups that are specific to some spaces, well, Hacker Garage and Rancho. And we got a total of 8 responses. All of the respondents were male. All of them were over 30, about half were over 40. 2 from South America and the rest from Mexico, most from the center of the country. There was one specifically from the very south. Their first system, which corresponds to the age, right, is one of them responded it was MS-DOS, another one was Windows 3.1, and the rest were either generic Windows or XP or 95, right? I didn't mention 95 there. Now, it was important for me to kind of convey what other people think in the Latin American scene about what does being a hacker really mean, right? These are the responses. We can basically run through them. Challenging is one way of thinking to create something different and thereby break the system that ensnares humanity. So the main revolution is to hack yourself. Collectivizing knowledge, learning about technology tools and sharing them with others. Someone who plays more with their computer, right? So curiosity, building and dismantling programs, hardware to see how they work and researching the subject for sheer pleasure. A person willing to help and see things differently. So this is like a community meaning, right? Someone with a curiosity about their passions and who is open to learning from others because they know they don't know everything, which is to say a word about how, and we'll talk about it a bit more later, right? But one can never know everything. It's always good to combine one's knowledge with the knowledge of others. Community spirit and collective learning. Someone who enjoys learning beyond the basics and creates additional uses for things beyond their intended purpose. Understanding something, deepening knowledge, practicing, sharing, creating solutions to everyday problems, suffering, and enjoying the process. Knowing a system or parts of it well enough to use in ways it wasn't designed for, right? So this I like to think of as the broad sense of the word hacker, because obviously the modern meme around the word, and by meme I mean the meme in the Dawkins sense of the word, is obviously someone who breaks into people's Facebooks, right? And that is one of the stereotypes that we are actively trying to combat. As a funny thing, since we have this space here inside the museum, and I'll talk about that in a bit, I have an almost unending stream of security guards who they change here over time, right? So every time there's a new security guard in the museum, on the first week that he's here or she's here, they come to me and they ask if, am I the Russian hacker guy? And I say, yeah, that's me. And so they ask me to help them do something on their phone, right? And obviously they ask out of politeness if I want it paid. And obviously I say no, because this is one of those community services that this space just ought to offer people, right? Also, we experience something that cannot be an experience, which is another reason why it is important to us to have this space, right? So as I said, the first thing, Rancho Electrónico in Mexico City, it has been definitely the main exponent of the hacker culture in the country. It's a completely collective collective. They are now, if I'm not mistaken, in their third space since they began this project a long time ago. And even though the number of people vary and the number of square meters available also has varied with time, it's still going strong. And well, if you can look them up and see if you're interested in collaborating somehow, that would be awesome. As you can see, Richard Stallman visited them a while ago, but he was there. So that's another thing to mention, right? Then we visited Hacker Garage in Guadalajara, where, by the way, I'm going to show you. Sorry about that, but I got this hacker space passport in Hacker Garage several years ago. Super proud of having it as well. They have an awesome space. They actually do charge a membership fee, but also come with many perks. Some of you might know that Guadalajara is often called the Silicon Valley of Mexico. So the people that go there, first of all, there's more of them because there are more tech companies in the city. Yeah, they have all sorts of sponsorships, and they're more of an institutionalized hackerspace, maybe even closer to a makerspace in some senses, okay? Nevertheless, an amazing space, and if you're ever in Guadalajara, definitely visit them. If you hear that background, that's one of the normal things in the museum here. There's always something happening. So let me shut the door real quick. Very fun place to be, definitely. So shout out to Electronicats, which are the people from Aguascalientes that I mentioned. They are now making open hardware, and the stuff they make is really cool. So no matter if you're into red teaming or if you just want to design and make a new badge for your upcoming con, these guys are great. So I had the opportunity to visit the CCC in 2016, and to me that was a life-changing experience. For the first time, I realized that a space is possible. You know, that if you can combine close to 20,000 people over 5 days in a Congress center and just make it live by different rules, then why can't you have a temporary or a semi-permanent autonomous zone somewhere where people can just go and hang out in the same way every day of the year, not just between Christmas and New Year, right? DEF CON is obviously also a big inspiration. So yeah, you know, you guys know more about it. I haven't been there. I've been told and I've watched, and I'm really excited to sometime be there, but you know what I mean. And BuckCon is a new con in Mexico City that is happening now yearly, which is also a nice group of people and is part of this community. So how did this happen? The original kernel panic room was just one room filled with old furniture. We rented it from this dude who stopped renting the part of the house that he rented. And there was a library and there was a beer bar. And so since that guy was the one who had the beer bar and we thought that nobody would come to our cultural / hacking events if there was no beer, we decided that we needed to open a bar. This is one of the few surviving pictures from that first space. As you can see, it was pretty NSFW. So this is the first version of the post-apocalyptic bar that we opened. Unfortunately, it became so cool that it basically swallowed the energy that we had for the hack space. And even though we tried talking to people at the bar about hacking and about Linux and about using free software, well, let's just say it wasn't the first thing on their minds. So it didn't triumph as a way to attract more people to the hackerspace. So yeah, it helped, but not the hack space. Then we moved to a bigger house, but the bar got better and the hack space got less understood. So this was the second version of the bar. Shout out to La CCC, which is, so CCC is obviously a little reference to the German CCC as well. It's still a nice cultural center to be in if you ever visit Querétaro, but nothing to do with hacking anymore. We tried making propaganda. So the one on the left is Gary McKinnon. If you don't know who he is, he purportedly hacked into NASA at some point. And on the right side, that's one of our members, Javier, who comes to this space, and he has a key. And well, that box was empty, but it was a great picture for propaganda, you know? So something that I need to mention is that I don't have a formal background in anything technology. I studied international relations, so I specialize in propaganda and I love to make it. And now I'm using my powers for good because, you know, what could be better than fostering the use of free open source software and visiting hack spaces. So this is another one of our propaganda posters that some of you might find funny, some of you might find offensive, but you know, that's just how it goes. In 2019, we were trying to organize a little con called Hack Meeting. So this is something that has been going on for years, and we just asked to be the hosts of the event for 2019. Unfortunately, our bar got closed down for a week or 2 weeks, right? A week before the hack meeting was going to happen. So I asked the director of the city museum if he could lend us some space to make it happen. And he did. And actually, this room you see on the picture is just next to us here. So if I go out, the door to the other room is right there. We aren't using it right now, but you know, eventually, fingers crossed, we will conquer it as well. And this is the poster that we made for that occasion. And then came social decay. So the cultural center and the people involved in it started infighting and basically demanding that the hackerspace has to generate money for rent. And well, Hackspace and the bar kind of came together. The hackers, we just left that project and we stopped having a space for a while, and the bar lives on, right? But then came COVID right after that whole commotion. And so spaces became basically irrelevant at that time, right? And that became a real issue because Rancho Electrónico had to close down. Hacker Garage also had to close down, and they're just this year resuming activities. Thankfully, both of them, which is really nice. And so the question stood afterwards, and you know, we had time to think about it during COVID. What's the relationship of it all? You know, what's the point of having a space? And so, thinking about it, I think that the conclusion is the following. We like hacks, right? Hacks are fun. hacks are interesting, and there's an infinite amount of things you can do. And so that makes us hackers, right? And for hacks to exist, there have to be hackers who hack them. But sometimes it's not enough to be just at home hacking. So you need a space. So this is the triad that we're implementing here. And there's a whole debate between hack spaces versus hacker spaces, right? Is it more important to have hackers in a space, or is it more important to focus a space on the hacks and have hackers just come and go and participate or not? And I think that it's important, but even if there's just one hacker, there already can be hacks. And if that hacker hacks in a space, then at some point more hackers will arrive. That's something that we've experienced here, right? There's very few of us, but those of us who are here most of the week, whenever it's possible, because this is our third space. If you don't know what a third space is, unfortunately, I would love to talk about that, but there's not much time. But do look up the term and read up on it. And I think hack space is specifically one of the best ways to exemplify what a third space is, third place, sorry. So obviously one of the reasons also is, as I said, space. This is my home lab, which started growing and growing during the pandemic. And as you can see, that old ThinkPad X220, which is core booted, of course, and which I use as a home server, has Adidas speedlines, so it runs a little faster than normal. One of the things that I wanted to do was to just free up space at my place, and all of the equipment that I had, I brought here, and that makes a whole lot of difference. This is how our hackerspace looked the first few days. So right there, you can see about a third of the room. On the right side here, these black boxes are ecological ovens of some sort, which are very unwieldy, and so they came and went at least a couple times a month for several months. We got rid of them finally last week. The rest of the room that you don't see is in this picture is mostly covered in chairs and other stuff that was just here as used as a warehouse, right? So one of the big things that we had to do was to find a way to talk to all the people involved inside the museum, to organize another space and to have some help to move it and so on. So having this here is also a diplomatic challenge. Now, we focus on making some propaganda as well. So this is the newer propaganda, and of course, the other version of that same propaganda. Again, some people might not like it. I think it's just brilliant, but maybe that's just me. You can tell me in a bit. And this is some of the other stuff we've made. Now, I would like to show you something else. I have a little video that I made, and I think we still have time for it. I want to show you how the museum looks and how do you get to the hackerspace once you're inside the museum, okay? So, if I can just move this window. Okay, yeah. It's a little glitchy. Now, you have to forgive me. This is also a very old ThinkPad. So that's just how it is. Okay, so this is the main entrance. You can see here, this guy is one of the most legendary poets. They called him the vampire. And there's a statue of him sitting right outside the entrance to the museum. So this is our lobby. That's one of the guards saying hi. You walk in a little bit, it's right here. People leave their bikes. That's the bathroom, always important. And then here on the right, that's just one exhibition. Upstairs, there are more rooms with more exhibitions and with more workshops as well, dedicated to different things. This is the courtyard of the dogs. That's what it's called. This here is the, if I'm translating it correctly, it's the Moorish patio. So if you walk down that dark hallway on the right, you can get to the children's library. And then we go back. So outside this door to the left, behind the dog patio, you get to a big forum. And there's also a carpentry shop or a wood shop. It's not technically ours, but we're friends with the people who administer it, so we use it. And so you go further on. Here to the left, it's the administrative offices, not much interesting there. Well, we have a copy machine that we can use. And then you get to the other courtyard. This one, I don't think it has a name. And then you go down under the stairs in this little tunnel that looks kind of creepy. Not many people wander in there, and maybe that's part of the natural selection of people who would and would not like or be liked in the hack space. We like all people, but some people, you know, if you don't understand what we're doing, then it's difficult to convince yourself sometimes. And so this is the room I am in right now. Sorry about the mess. We're still, so this stuff on the left that you can see here, it's all artwork that hasn't been given back to the artists who brought it to the museum for an expo. So we're waiting on that, but we're doing the best we can. So on this side here, we will have a little, these black chairs, like a little sofa cushion space, and a little library. And then on this side, this is the big table for everybody. And then here you see, obviously, this is the password to the Wi-Fi. This here table is our old hardware table, which I'm going to show you our crown jewel in a second. And here on the left side, we have our 3D printer on top of a safe that we haven't opened yet. This here is the desk where, well, that's the soldering station. And this here on the right is the propaganda station, just so you know that we have one. I could show you some pictures of the museum as well, but let me disconnect real quick here, and I'm gonna show you our crown jewel, and I think I'm gonna end that on it. So if you walk with me here a little bit, it's not that much walking, you know. This here is a ThinkPad T400 that has not Core Boot, LibreBoot installed on it. For the longest time, we tried to get this operating system installed on any computer. We tried like easily 10 different laptops of different varying oldness, and none of them worked until we tried on this. And so I'm not going to spoil it for you, but I would really like to hear some responses from the public. Does anybody know what operating system is this? And as a bonus question, does anybody know who is this elephant right here? And well, welcome to Kernel Panic Room, aka Cuarto de Máquinas, which means machine room. I hope you've enjoyed our visit. This here is our temple, and that's our main server. We accept Saint Ignatius into our hearts, but we are not part of the Church of Emacs. We are part of the cult of Vim. So we can also have a theological conversation if you want. That's it for me. Thank you again so much for having me, and love and kisses. I'm not sure what to do now. If there are any questions or anything like that, please let me know. And yeah, keep in touch with us. Actually, maybe if I'm still streaming, I'm going to just open up this here page so you can know how to find us exactly. Kernelpanic.lol. I'm being told that there's a lot of clapping. I thank you very much. I'm really flattered. Yeah, and well, if I'm still there, here's our temple to entropy, just hidden in plain sight.
Test, test, test. Okay.
Oh, really?
Yeah.
Oh, yeah, you want my address to,
You have. I also brought an adapter. Do you have one just like handy? Sorry, what did you say was next? Is building Linux. Got it. Thank you. Okay, great. Thank you. Sorry for all the room confusion.
And recording, okay. All right. That's fine. Hey, that's definitely not the camera we want. Neither is that. Okay. We're going to turn that off now. Thank you so much for your patience. This is live and recording on the internet, and that's your microphone. Okay. I'll have to talk loudly. Okay, so thank you everyone for coming. Thank you for inviting me. This talk is called Building GNU+Linux from Source using LFS and the Build Project. Quick introduction about myself. My name is Tree Davies. I live here in Seattle, Washington. I am a site reliability engineer at Google, and I'm also a ham radio operator. Any ham radio operators here? Right on. It's a really fun hobby. You learn a lot, and very low barrier to entry in terms of cost. But be warned, you will start acquiring hardware very quickly. The 4.5-foot antenna in my living room is subject to that. So yeah, so I've been using Linux since about 1996. I think what really attracted me to it was the really kind of like the punk rock attitude of doing it yourself. And I just really love the idea where, no thank you, I'm not going to purchase a license and use software that I do not have the right to manipulate or understand how it works. I'll do it myself, do it with my friends. So the very first distribution that I installed was Slackware, which was started by a person named Patrick Volkerding. And I was really in love with that OS for a long time. It was just an endless amount of research, and I could just dive deep as I wanted and do any experiments I wanted. It was mine. It was also yours. And that led me to this idea of building my own distro, and that led me to Linux from scratch. So what is Linux from scratch? It is a free online technical manual that guides you through command line for command line on how to build a very primitive, very basic Linux operating system from source. It was started by these two guys, Beekmans and Dubs, and for the last 30 years, they have published a book or a new version of their book about every 6 months. They also publish other books as well with different goals, but none that so popular as the very first one, which is LFS. And so they've also built a community around this of people who really care about being able to build the complete GNU Linux stack. They mostly engage with one another on the mailing list, and they're there for fixes, for security updates, as well as assistance. So once I did this project, I wanted to do it again, and I wanted to change it, and I wanted those changes to not be something that I would forget to do the next time. I wanted something that was a reproducible build. So I started this project called the Physics Project, and I'll talk a little bit more about that later, but the main idea was to make the build process easy and the ability to share with others. So this is my two-part agenda. I only have 30 minutes, so I have to speak generally, but I'm going to take you through the general build process of LFS, and then I'm going to talk a little bit about physics and how it can make your life easier, or not use it. I heard somebody mention BuildRoot earlier in the crowd. That's another alternative. Fully support it. So yeah, so what are we going to need? We're going to need at least a physical machine or a virtual machine. I've done the project using both cases. There's really no difference to the experience. So you'll also need to be running some version of Linux on your host system, whatever you choose, to your preference. And then you'll need at least a 4-core Intel-based CPU. You can do it with less, it'll just take longer. 8 gigabytes of RAM. And you can also do this just using one disk. And that is, you will be using your host system, which will boot off of your host partition, and then you can install to the secondary partition. However, I recommend not doing this, keeping those two worlds separate. is advantageous because you will quite possibly break your system. And keeping them separate, you'll avoid that. So before we start building an entire OS stack, how do we build one piece of software? So there's this repetitive compile process that you'll see in 99% of software, at least within the Linux environment. So the first thing you'll see once you extract your tarball is there will be usually a configure script, which is usually written in Perl or Bash, and it's basically going to poke and prod your system. It's going to look for all of the dependencies and make sure that your system is capable of running the software that you're about to install. You are then going to probably see a file called a makefile. That makefile is the configuration file for a program called GNU Make. GNU Make is like the maestro. It is the orchestrator of the build process. Essentially, it's the driver for your compiler. And once your make is completed with its task of converting source code from the developers into binary images, you can use make again to install it onto the system. And you will see this over and over again. If you've done it once, you've done it 1,000 times. So preparation, you're going to have to download about 60 source code packages. The book itself provides a file with all of the URLs to where you can find everything. But a word of warning, the older the book gets, or that version of the book, the less accurate those URLs are going to be. So you may have to do some hunting. And then we're going to prepare our disk. So we have this host system, and then we have this secondary hard drive, right? And so what we're going to do is we're going to want to lay down a partition table. This basically tells the system of where bytes will start and where bytes will end on the disk. We're slicing up the pie. First time recommendation, just partition the entire thing. And then we'll have to format it. You can use any file system you choose or you want to, as long as the host system kernel supports it. But extension 4 works perfectly well. And then once we have this disk ready, we can mount it onto the host system under this path, mount/LFS. And keep that path in mind because we're going to see it again in a second. And now we can use it like any other storage medium. And so now that we have this disk, we're going to create two directories. First we're going to create a directory called tools and sources. Sources is basically what it sounds like. It's where you're gonna copy all of the source code packages that you just downloaded. And then we have this tools directory, which is going to come into play in the first phase of the build process, which is called building our tool chain. So the tool chain is just a series of tools, source code projects that we're going to use during phase 2 when we start building the core system. So when we compile and we build these tools, we're going to install them in the tools directory. And so I'm going to talk a little bit about some of the key tools, since I can't go over all 20. But I'm going to start from the bottom. I'm going to start with the very first source code package you're going to compile and install is bin-utils. This provides you with the x86 compiler and linker. This will compile and translate assembly language into binary. So once we have that, we are also going to install our GCC compiler, which can read C code, convert that into assembler, and then assembler can convert it into binary. And then, so now that we have a GCC compiler, we want GCC to understand that what kind of system we're going to be building. So we install the Linux kernel header files. These are the API for all the functions that the kernel provides. And then we have GNU+Libc, which is basically the powerhouse library of open source. It is also the system call layer that separates user space from kernel space, so such that when your program wants to make a system call to the kernel, it's actually going to be making that call to glibc. And glibc acts sort of like a telephone operator and relays that message to the kernel once the processor flips over into privileged mode, and then sends back returns when it flips back. So now that we have this layer, we can start focusing a little bit on user space applications. And the first one here is bash. So we're going to install a shell, and then we're going to install the core utils package, which gives us all of those tools and utilities that we take for granted every day, like cd and makedir and cp. And then we can install, of course, make, which we already discussed. So in phase 2, now that we have a tool chain, we're going to do something kind of interesting. We're going to use this command. It's called chroot. It's a command line tool named after the same system call, which is called chroot. And it's sort of like the cd command when you cd into a directory. But in this particular case, we're going to chroot into this directory. And what we're doing is we are telling the Linux kernel on our host system, we're telling the virtual file system layer that we want to treat this system path of mount/lfs as if it were our root file system. So you chroot in there, you type ls, you get a slash. And what we're doing is we're separating the host system from the system that we are now creating. And while we're in there, we're going to execute bash, the bash program that we just executed. So now we have a shell, and we have all those core utils that are all located there that we just built. And so in this stage, you're going to basically compile almost everything over again. You're going to take several passes at GCC and bin utils to get it where it needs to be. And then you're going to basically do that repetitive compile process on like 60 packages. You're going to spend hours doing this. The first time I did this, I think I spent the better of like a 3-day weekend, and I think I took Tuesday off to finish it. So again, automation is good. And so once you're finished with this phase 2, we move over to the configuration phase, where we're going to build. We're still in a chrooted virtual environment, by the way. And we're going to build and install grub. We're going to compile the kernel and install that. We're going to set up, fstab and resolve.conf and all the key config files that you would expect. And then the very last thing you do is you'll set up your users, and you'll set your passwords, and then you should boot. And then it probably won't boot. This is the part where you learn a lot about troubleshooting systems. You get obsessed over error messages and log files. But it's a great learning experience. And then maybe you'll want to do it again, or you'll want to automate it through buildroot, or maybe through the physics project. And so this became this project that I was like, I want to do this better. I want to do this faster. It started off as bash scripts, which was a total mistake from the first go. But I wanted a way to make it really easy, press the button, build my system from source, and also make it be a way so that I could share it with others. And by that I mean making it a Git repository that people can pull from, they can send patches to, and the like. So essentially, physics revolves around a centralized tool. It's a multi-tool that I wrote in Python called Catalyst. And instead of, we just talked about these 3 phases. Well, let's rechange the terminology here to phases to recipes. And these are just basically config files that for each recipe, or for every phase, we have a config file. We feed that config file to Catalyst, and it builds out all that software for us. So let's talk a little bit about recipes. This is the first element. Again, JSON, bad idea. This is the first element of the tools recipe. This is for bin utils. It essentially says, so phases, recipes, and also referred to as build groups. This is the toolchain build group. Of course, I list out the archive that's being built, and then the URL which it can be downloaded from. So with physics, all the source code that you need to build is located on physicsproject.org. And so this is sort of a demonstration of the organization of the project. So if you go into the build groups directory and you list out what's in there, you're going to see a bunch of directories with the same names as the recipes. And then if you list out the very first recipe, you will see all these directories representing all of the packages that get built there. And then if you list out the binutils directory, it contains a build.sh file, which is the all of the shell commands that you would run to build that particular source package. So before we can actually start building, there is a physics.conf or config file that we use to set up our partition tables. Basically, there's a lot of configuration options in that file. There's only 7 config options that you're actually mandatorily supposed to configure. These are things like which hard drive are you installing to, the partition, are you wanting to boot using UEFI, or if you're using a primary legacy BIOS bootloader. And other than different from LFS, I've also been using logical volume management, so it sets up your logical volumes, and then it mounts your hard drive, and then so it sets everything up for you. And so at the end of that script, basically, you should see this from LSBLK, which outputs your partition table. And so SDB is all set up to be built for building physics. And so here's the 3-phase process. Here's the 3-phase build process according to physics. So we have this dash pull flag that you run against the recipe, and Catalyst will download everything for you, all of the source code for you for that recipe. And then in terms of the tool chain, the system build phase, the configure phase, you just run those flags against it, and then you can boot your system, and it should boot the first time. Fingers crossed. But then I got really crazy with this, and I started just continuously building more recipes. This is a very primitive system. It is not something you would ever want to run in production. So the first recipe that you should probably build once your system boots is the utilities recipe. This contains all your security updates or security packages that will keep your system will make your system a little bit more hardened. I'm not a security professional, so I'm sure there's some vulnerabilities in here. So don't put it on the public internet. And then services, things like DHCP clients, there's a Apache web server in there, Kerberos clients as well. And then the last 3 here, actually, I don't really do much with, but I did build LXDE. It was like something around 300 packages that had to be done. It's not fun. So use at your own risk. Yeah, I had a window manager working for a while. I installed the beast, which is Firefox, and yeah, I could watch YouTube. So another thing that's kind of nice is Catalyst also provides a way of tracking what you've built so far. So every time it builds a package, it basically writes an entry to a MySQL 3 database, and you can keep track of your system stack as you build it. Another thing that it also does is for every package it builds, it keeps the build log for you. So when you do have build problems, or you're trying to resolve those build problems with friends on the internet, sometimes it's easier just to email them the build log than to try to explain what you're seeing on IRC. So the file system that I chose for this project was btrfs. I really like the idea of snapshotting. It's a feature that allows you to take a picture of your file system in time. And so that way I could take a snapshot when I first boot the system. I can do my experimentation, play around with it. If things don't work out, I can reboot to that previous snapshot. And it's like nothing ever happened. And then you don't have to spend 7 hours rebuilding again, just to do it over again. So looking forward, contributors, thank you, please, and welcome. Ideas of what I would love to see happen with this. It's definitely time for package management in some way, shape, or form. I really like Arch Linux and how they do things. So I'd love to see some Pacman packages. I would love it if somebody were to own building GNOME from source, which is a feat in and of itself. And also, I've been playing around with this idea of having a bootable USB drive where you just plug in, boot up, start building from source. And other than that, physicsproject.org, I've got demos on YouTube, and there's a virtual machine you can download and play with as well in VirtualBox. So with that, wrapping up, thank you to SeaGL for having me, and thank you to the Linux from Scratch community for all they do. And I'm kicking myself because I forgot the stickers. So I will be back tomorrow, and I'll put them down on the sticker table if you take as many as you like. So thank you very much. Oh,
so I'm just curious, is part of the reason for building from scratch just to appreciate the complexity and the depth and breadth of everything that is part of Linux?
Yes. I mean, that is one of the things that, and also it has really taught me, like, as a one-person distro, like, how valuable community is. You know, many hands make light work. And it really makes me, it has also taught me to appreciate just the vastness of everything that works together. It's kind of insane how well it works together.
And is it also maybe just a security thing to just, you know exactly what you are putting into your code or you're putting into your distro? Because sometimes I find that developers, especially in the age of package managers, they don't even know like what transitive dependencies they're pulling in. You know, they're kind of, I pulled this thing in and they had no idea I brought in another 100 things. So this seems like a more pedantic and conscious choice.
Yes, yes. And I guess I was also going to say, I forgot what it was. But yeah, I mean, if you choose to go that deep, I mean, for a basic system like this, you know, it's just 60 packages and you'd have to go really deep yourself. But if you're interested in security, there's no better way to like really learn and teach yourself by really examining your system for what it is. So, and also I would add, if you are kind of a super nerd like me and you want to squeeze as much performance out of your system as possible, building it specifically optimized on your hardware, you'll get better performance than if you were to use an already built system.
Does the LFS book teach you how to optimize? Or?
They talk a little bit about it in the GCC part. There's a couple flags you can switch, which is also a flag you can flip on in physics as well. The downside is to that, if you optimize for your hardware, you can't take that hard drive out, put it in another system with a slightly different processor, and expect it to build everything for you. So general builds, much more general across the CPU spectrum. Okay.
Okay, so you get it built, and you start it up, and you boot into LFS for the first time, and it's working.
Mm-hmm.
So you basically just kind of have the basic commands like ls, cd. I mean, is there really anything else that you could or would want to do with it? Just the basic LFS?
Well, you do have a version of Python and Perl, so you can start coding there, and of course you have the C compiler there at your disposal. There's not a whole lot else there for you. I mean, you're going to be able to use grep and tools like sed and things like that. So it's very basic, but you won't have Rust installed until you install the utilities package. You won't really be able to use email. You won't have a window manager or anything like that. So, yeah, thank you.
The first time you do it, it's much more about the journey than the destination.
Yeah.
It's learning how all the pieces fit together as much as it is actually having a working Linux system at the end. Because I can download, Ubuntu or whatever and have something up and running in an hour, but you're not going to understand how you got here.
All right. Well, thank you so much. Oh, did you have a question?
Oh, do you build the sysroot and the compiler separately so you can like cross compile for the end result, or is it purely self-hosted?
I haven't done that before. It's possible though, right? Yeah. All right. Thank you so much.
Oh, thank you. Does anybody in here happen to be James? Does anybody know where James might be? Nobody? Okay. Let's double check this. He's supposed to be, yes. However, we don't. I don't think we have a James. Are you James? Okay. Well, it sounds like we have a no call, no show for this time slot of. You want to double check these? We're gonna double check that.
Make sure you do go to the other room.
Yeah, yeah. They might. Well, oh, hey. Oh, he's here. He's here. James is in fact here. Okay, so this.
Image-based stuff, I have to get into that. And I know that I'd like it if I did it, I just, you gotta pick the time. I was one at the time.
Yeah, so this block is pretty.
James is here. Oh God, what am I doing? My muscle memory says I'm still on my laptop. Sorry, tech difficulties, 1 sec. I need to switch OBS. I need to switch OBS over to
Hi, everyone. My name is James Panicciulli, and let me go ahead and share my screen here. Okay. So hopefully you can all see my slides. Oh, we're a deep trip down the abyss, I think I just gave you. So yeah, I'm here to talk about simple site hosting with lightweight Kubernetes, which is relatively straightforward. And hopefully I do this talk some justice. I ended up having to throw it together at kind of the last minute here, so I apologize for that, and then had a few technical difficulties, so sorry about running late. So let's just jump right into it. Just make sure there's nothing okay in the chat. So yeah, simple site hosting. I'll put these slides up later. I'll throw a link somewhere for them. There we go. So Kubernetes is a wildly extensible, configurable, enterprise-grade orchestration platform which drives many of the largest presences on the web. So let's use it to host a few small static sites. The whole thing can seem kind of silly, kind of overkill, and I don't necessarily disagree with that. It does get you a few benefits. Kubernetes obviously comes with some advantages. There's reasons that it's in use everywhere in every big company and small company alike. It's extensible. Everything's containerized that runs in it. So if you need different web servers running, different software stacks and all of that, and they can all share an IP if you need to, stuff like that. It's pretty easy to run a wide variety of applications through one server or one set of servers, so one pool of resources effectively. And it really allows you to kind of manage a lot of things through one interface, which again is overkill for a few small static sites, but it does allow you to scale up from that point, and it automates some nice stuff like Let's Encrypt certificates are super easy to do with Kubernetes. You just use the Cert Manager plugin and configure it with Let's Encrypt, and you tell it about each of your sites that you want to have a certificate for, and it automatically does the challenge and so forth. So we'll see that in a little bit. It's resilient. Your containers are automatically restarted in case of failure. It's up to you to notice, I guess, if they are in a failure loop, but it'll give you some nice diagnostic information if so. And the main reason people probably do this is for experience with Kubernetes, since if you don't work at a huge company with Kubernetes, it's a bit daunting to get into because the solution space in the Kubernetes world is vast. And let me show you what I mean. I think most Kubernetes talks that I've seen have referenced this map, and it keeps getting bigger and bigger, and you see all the icons struggling to load. And so these are all of the different possible components you can swap in and out for each other at each stage of the Kubernetes ecosystem. So it's a lot, a little bit too much, really. So that's why we're just going to go for MicroK8s, which is Canonical's lightweight Kubernetes distribution. And just being lightweight doesn't mean that you can't scale it up to have multiple nodes and so forth. But I run this for several of my own sites and for testing purposes, and it runs really well, even in a small VM, like a 2 gig, 2 CPU kind of EPM is more than enough if you're just doing simple stuff. Give you a tour of that, but so we're just going to basically install snapd. So this works best obviously in an Ubuntu distribution, but you can obviously install Snap on other distributions as well. And then we're going to install the microcade Snap. We have to give the -- classic flag right now, which means classic containment in the Snap ecosystem. And classic is kind of a fill-in word for not contained. So classic being like the old apt style of package management where it has more access to things in your root file system than it should, given that it's a Snap. So I believe that Canonical has been doing a lot of work towards being able to package microcades reliably in a way that can be properly contained. But for now, the latest stable versions, you need the classic flag there. And then you're going to want to add your user to the group and refresh your groups with the new group command or reboot the server, whatever you want to do. So we could go here, and if I'm on a server that we have this on, I was going to bring this this server back to nothing, but I didn't have time for all of that. So I can just show you that I have the Snap installed. If you Snap info microcates, you can see all the different versions that are available. So we went with latest stable, which is 128. And you see there's different options available. So basically, once you have it installed and you have your user set up, you can run microcates, and it's good to go. So to configure it, the first thing you want to check is microcade status. And so here, let me make this a little bit bigger in case it's hard to see. Here what you see is the add-ons which are enabled and the add-ons which are disabled. So just to show you there's no tricks here, let me disable the two add-ons that didn't come by default. So that's Cert Manager and Ingress. And then the next thing we'll do is enable Cert Manager and Ingress so that it's a true live demo. So we'll give that a minute to run. Okay, I had some stream issues. I hope those are doing better. Okay, that's just taking a minute there. So the other nice thing about working with Kubernetes is that you can get lots of Helm charts to enable things like setting up your own Jitsi Meet server, which requires a little bit of extra tuning to handle some UDP ports and stuff like that. But you can add a lot of things into the mix once you get going, as long as you kind of put your YAMLs in version control so that you can go back to previous working states if you bungle it all up. All right, so those are disabled now. So we're going to go back and we're going to enable them as if we had just installed the Snap. So once these are enabled, I'll come back to that in a second, we're going to put a simple site in an Nginx container. We can use any container. It doesn't need to run Nginx. It doesn't need to do anything in particular except be able to serve some content on some port. The configs that we have expect it to be serving on its own port 80, but all of that is easily changed, as you'll see. If you want logging to be transparent through to the host system so that you can see it with the kube control commands and so forth, you need to make sure that it's either running in the foreground so that it's just outputting on standard out and standard error, or do like the Nginx container itself does, and you can actually symlink the log files that it's writing to dev std out and dev std error. So that's an easy way to kind of convert any container that you otherwise have into something where the logging can be picked up by Kubernetes and make it more easily accessible by other kind of observability tools. And that's the Docker file that I use for my sites, right? It's very simple for any kind of simple site. You just take your HTML directory and pop it in where the default Nginx config expects there to be an HTML directory, and that's it. Obviously, you can customize all the things about Nginx that you need to, but you don't have to do that if you don't want to. So, to keep things simple, I put a lot of this into a Git repository. So I have that in here. And so if we go into SeaGL 2023, I have the generic Ingress YAML that I kind of base all this off of, but we're going to go ahead into this directory, and let's check out my static sites first and foremost. So we have SeaGL 00, my first example. I have a Docker file in there. You can guess what that's going to say. From Nginx, copy HTML, user share Nginx HTML. Great. Bonus use of cat there. Similar to a useless use of cat, but that bonus one. So if we go into, can't type. If we go into here, we can look into my HTML directory. I have an image and an index, nothing fancy. And we can see that it's the same over here. I have two images and an HTML file in the HTML directory for SeaGL 01. So two very similar example websites, no big deal, right? So what we're going to do is build and tag the Docker image with a fake registry for sideloading. Now there's a couple reasons that I do this. You may have noticed if I do microcates status, they do have a registry. The microcates registry, if you look at the documentation, it says, look out, this isn't secure. So I figure it's best to avoid it. Luckily, microcates already comes with its own images kind of internal repository for OCI images, which Docker images or OCI images. You could also build things for this with Podman or Builda. You don't need to use Docker itself. And you don't need to install Docker on your server. If you don't want, you can build your Docker images or whatever images on any other machine and just throw them over there. What's important is that you have a tag you can locate them by when they're in the internal registry. So that's what we're going to do here. We're going to build with a tag, and this is completely arbitrary. I made up the domain microcates.sideload as kind of a catch-all for the things that I know that I built for my microcates. So microcates.sideload, it can be whatever you want, slash, and then the name of your image and some kind of versioning scheme for when you need to update it so that you can keep things kind of in order and know what's going on. So very simple, right? We're just going to build the image with our fake sideload domain as part of the tag. And that's how Docker, normally if you were going to push to like a custom repo or something, you would do it this way as well with a tag, a custom tag with a real domain. So we're going to do this with a fake domain because we don't need it to actually resolve anywhere. We're not running a registry. We're just using the internal microcates system. So we're going to build it with that tag, and then we're going to use the Docker save command, which you can use to output to a file, but instead we're going to pipe it right into microcates image import. So let's see that at work. So we did that with the SeaGL 01 image, which we now have. And now we will import that. And that'll take just a few seconds to run as it copies all the data over. And so once we have that, we can go ahead and list the images. There's a lot more images than you'd think because they are, there's a lot of internal images as well. Okay, so this is the output that you expect, pushing OCI images. That's how you know that it's complete. Okay, there we go. All right. So if we do images list, like I said, it'll be a very long list. So let's grep the ones that we're looking for. And so here we can see I've already side loaded. You can see my tags here, microcates.sideload.siegelO1.cates.jp.net, and the rest of the metadata about it. So that's how you inspect what's in the current registry. And microcates is smart enough, I believe, to flush those out. And I think there's some parameters you can tune somewhere about retention and so forth. So it won't waste space for things that you clearly don't use anymore. So once we have all that in there, we are ready for our YAMLs. So if we look at one of our YAMLs, this is a basic YAML, right? We repeat ourselves a lot. We're just going to say the name of this thing is SeaGL1CagesJP.net, which is very similar to the domain name, which is SeaGL1.cates.jp.net. We're listening on port 80. This is our image tag. This is what we're looking for in the side-loaded microcates kind of repository internal thing, right? So we're looking for version 000 of this image. And down here, we just set up a service. So up top, we have deployment, and down bottom, we have a service. Again, we're going to choose a very similar name. There's no reason to use different names all over the place. It'll just confuse you later. Try to use the same kind of strings that are allowed in every place where you can. That's my advice. And so this is our selector, and we're going to use all of this basically to look it up later from our Ingress. So oops. Let's make that a little wider. Good. So our Ingress controller on the left, you need to specify some of these things by default, just the API version and so forth. I added several annotations here. You don't need them all. However, this one was important. This threw me off for a little bit when I first started with microcates. The default Ingress class name is public in microcates. A lot of other tutorials and guides you find on the internet assume that the default Nginx Ingress class name is Nginx, or sometimes default. So this I had to kind of stumble through the hard way before I knew what I was doing. So the Ingress class is public. That's the important one. And then here, the cert manager, we want to set that to Let's Encrypt. So that's important if you want to use HTTPS certificates. And then for the rest of it, I also enabled some mod security with the default OWASP rules. Probably overkill again just for static sites, but better safe than sorry. So you can use that basically as a template and tweak it or turn it off if it gets in the way with whatever you're doing. But then for each host, you just want to set the host name. Right, so here we were looking at SeaGL1.cates.jp.net, and we're just looking to redirect that to / on port 80 for this service that's running as its own pod based on the deployment that we define up over here, this deployment. So these are all available in my Git repository. So you can just copy and kind of replace with your own values if you just need to get up and running. Down here is where we do the nice business of getting our certificates installed. So we once again are respecifying the host names, but so under the TLS section, right down here, we're going to put each of our host names and then give a new name that's going to specify the secret. And once again, I keep everything the same and then add -TLS just so it's easy to remember and find things in the code. No need to get too creative, right? So let's go down here. This defines our Ingress service, which also is going to serve on port 80. And it's going to select our Nginx Ingress microcates, which, in case you didn't notice, that is defined right up here. And at the very bottom is where I put the cluster issuer, which is what issues the certificates with Let's Encrypt. And you would replace this with your own email address, I hope. And then all this is going to do is use the HTTP01 resolver, which means that it's going to create an endpoint in HTTP that Let's Encrypt can query to do the Acme protocol certification to make sure that your site is who it says it is. And that's how the certificate is secure and gets issued to you. So great, let's see all that work. All you have to do is, and you can't put more than one of these on a line, apply. So microcates kubectl apply -f file name, and that's where you put the YAML. So this is telling me it's unchanged because I already applied it, and if you were making new changes, you would put replace, and it'll go replaced. And after you apply both of your site YAMLs, you want to go ahead and apply your ingress.yaml. Interesting. Okay, I needed to apply the Ingress YAML again because I removed the Ingress and the Cert Manager add-ons is what happened. And I may have just gotten ahead of the slides here a little bit, so let's go catch up. We saw the YAMLs. We can grab those from the example repo, which is here. So that's where the YAMLs are hosted. The link will be in the slides, which I will put up for everyone. And once we apply them, as we just saw, we'll be able to see the sites. So if we go to seagloo.kates.jp.net, we get a lovely site, a static site, and it was worth the wait. And we have a second site. If we go to seagull01.kates.jp.net, and this is literally the first time I've loaded this page, and it works. So live demos are a win. And with that, I believe that about rounds out the talk. Sorry again for the whirlwind and for being a bit late. The slides will be available at slides.kates.jp.net, but they are not there yet, so I apologize for that. But let me go ahead and put that here. So that you can see it bigger. There we go. So that will be the site for the slides. And I'll put that back up on my screen real quick. I'm not sure if there are any questions. I'll check back in just a second to see if there's anything. Stop sharing my screen. But I just wanted to give people a second to get that slides link. That'll be up within the hour. And sorry about the delay there. So slides.kates.jp.net. Okay.
Does your presentation include audio? Right. So this needs to go into. Oh no.
sysadmin kind of stuff. You know, I was doing just kind of a variety of things. And I started to get kind of bored with my jobs.
As it happens.
And I was kind of like, what do I want to do with my life? Do I want to just bop around? I would enjoy a job for about a year, and then it would get boring. So I had gone through 2 cycles of this, and then I was thinking, do I want to go try and get a job with a more cutting edge company so that I can be more on the bleeding
Okay.
edge? Of
You have
do I want
this
to
port.
go
Awesome.
get an MBA?
Are we good to plug in?
Management?
Great.
Do I want to just keep switching departments and companies and just keep learning new things here and there?
Do you see
Do I want
a new
to go
display
back to
pop
school
up
and advance my computer science
in
degree and maybe come up with a
in
different
your computer?
specialty? And somewhere in the mix of all that, I hit on law school as a possible way
Okay,
to
I'm going
leverage my
to
computer
restart the
science
capture card
background. And
because
I
sometimes
thought I
what
was
needs to
going
be
to
done
law
here.
school to be a software licensing attorney.
We may need to do
That
that.
was the whole area that I had decided to focus on.
Your
Once I
laptop
got
is?
to law school,
Like you know that
though,
about it?
as serendipity sometimes occurs, the United
Okay.
States Patent and Trademark Office released their guidelines.
So
for
I'm not
computer-related
getting anything from
inventions.
you, but that might be because
sudden, my
OBS is running.
background
So
combined with
here's
that
the
law
thing: we're gonna unplug
was
this,
magic.
and unplug this, and unplug that, and then
So
plug
I
them
just
in
had
a specific
this
order.
absolute
Yeah.
right time,
We've
right
got the
place,
magic
right
incantations down
background,
pretty well
and I
at this point.
graduated
So,
from law school and got a job with
do you
a
have
law
like a
firm
displays
in
menu
my
somewhere
area.
in your settings?
Now, had I gone out west at that point, at that time
Okay.
I was in Cincinnati, Ohio, which is very much Midwest.
I
guess it's not showing
If at that time
Okay,
I had decided
so
to pull up
we're gonna have
roots
to
and
restart
come out to
OBS.
Should I
California,
try a different?
I probably
Oh yes,
would've
yeah,
done
yeah. Go ahead and try a different port.
you know, and I probably would have had a completely different trajectory.
Oh,
for
okay, yeah. It's
my
I
career.
don't think it was pushed in all the way.
Oh,
actually.
okay. Hey, yep, there we go. I've got you. So your screen is
And
currently
even
on
though
the
I was
internet.
specializing
You might
in
want to
software
extend it to the
licensing,
side
did not
if you
come
don't want
across
that.
open source licensing. I
Like
was
it's live
looking
on
at
the
proprietary
Yes, this screen is
software,
mirrored
how
to
to
there.
draft
So if you go to your
contracts, I
display
learned
settings
how
and you don't want your
to
whole
look at
screen,
specific things,
like
study the
yes,
law cases
somewhere
that
there should be a
revolved
setting
around
to.
copyright litigation and patent litigation
Um,
associated with computer
Do you have
code.
somewhere where you can like drag
But I
the
never encountered
windows around?
open source because I think the professor who was running the program didn't know about open source, and so he never passed it on. And graduated,
Oh, there we go.
went to
Okay.
go work for a law firm.
Probably arrange
And
is
as I said,
probably what you want.
I ended up getting assigned to work on the mergers and acquisitions
then
team because
just click
there
and
were
drag it.
companies that were
I
our
think it's
clients that
your
wanted to
thing.
buy
Oh yeah,
computer
yeah,
companies.
yeah. That's probably what you
And
want.
the law firm
I don't know,
didn't really
Max,
have
so
anyone
you're
else
the
with that
expert here.
specialty in it.
All right, there you go. So that is, I don't know which side that's on, but whatever is on there, you can see it in here as well, Christina.
Oh, perfect.
You can also see this little preview window. You see it up there. This is currently, and this microphone is your microphone for the internet.
Okay.
This is live. That is live.
Okay, it seems like
Um,
it's to my left.
Then
Okay, great. Now your talk starts technically in 8 minutes. So can you do me a favor? When your talk starts, can you push the start recording button?
Oh boy.
They
Okay.
didn't see open source
Yeah.
as a path.
Thank you very much.
Okay.
Although
I'm going to go run down into
Room two?
room 1. I've already set up. Well, yeah, I'll go to room 2 first. Thank you very much, Christina.
Okay, that's it? Everything good?
Everything else is good. It works perfect.
And then from
Thank
there,
you.
I went to AWS, worked for them in their legal department for 3 years. Amazon Web Services. And then from there, one of my internal clients at AWS was the OSPO, the Open Source Program Office. I really enjoyed working with them. It was honestly the favorite thing that I had working on at AWS. And then I got an opportunity to move over to Hewlett Packard Enterprise, and instead of only having this slice of my work be open source, I kept all my work be open source.
Do you like this?
I love it. I love it. It's
Nice.
awesome. So that's my whole life story.
Amazing. That's inspiring because I'm still
So-
trying to.
With a social science background, you could go to law school.
I could. I mean, it's funny. I met someone who was a lawyer, and I considered, I was like, maybe, because I just liked the way they spoke. It was just very clear and concise in how they talked. But I guess I shouldn't judge all lawyers that way. But yeah, I considered it. Maybe.
It all depends on what your motivations in
Yeah, that's
being
what I
a
have to
lawyer
figure out.
are. It's a wide spectrum of talent and personalities. And depending on what it is you want to get out of life, it may or may not be the right choice. And I talked to a lot of law students. I was volunteering on this thing called Career Village, and someone was asking, what kind of law should I go into to make the most money? And I said, here's the thing. Money should not be the motivator if you're going into law, because the hours are long, they are hard, the work is intense, and at some point, there is not enough money in the world to make up for the fact that you have zero life.
Do you get set up okay?
There just isn't.
Seems okay.
And you can maybe do it for 2 or 3 years. And if your goals are short term, that I'm going to just bank for 2 or 3 years, and then I'll set my destiny. Then
See
great.
who comes on the other end of that.
Yeah, then great. Go do that. That's fantastic. You do you. But as a long career, just chasing the money is a never-ending, soul-sucking paradigm.
Would you say that you can offer this advice to someone who has been there, or you've seen it and seen where it can take people?
Definitely the latter. And I think to some extent, I don't think I got so bad at it, but what I can say is that in various jobs that I've had, I've always had a passion to merge tech and law together, and that's really kind of what carries me through it. But there are times that I have worked horrible hours. I mean, where I feel like my eyeballs are literally bleeding because I haven't had enough sleep over the course of a week working on a deal or working on an important set of contracts, or the stress of trying to do these things right is just sometimes overwhelming. And if I didn't have that, I think if I hadn't had the passion of, I really want to be doing this kind of work to help merge and deconstruct the mystery between law and tech, it would never have been worth it. And there were many sacrifices. My family had to deal with sacrifices as I pursued this to try to get to the job I have today, which I kind of feel like is the culmination of all of this work over the past 20 plus years. However, if your goal is money, if that had been my motivation, I just can't see that I could have sustained that. It's not worth it in the end. There's more important things in life than money. I mean, you need to have, you've heard Maslow's triangle, right? Because you're in social sciences. Yeah, you need to have enough money to satisfy the lower end of the triangle. But then there's a point where you're really not gaining that much just because you have more money, more social status, more stuff. It's just not worth it. I'd rather have a Sunday afternoon curled up in my cozy chair reading a book.
Yes, yes. I agree.
What was your name again?
Julie.
Julie.
It's okay. I'm Ria.
Yes.
How do you spell it?
R-I-A.
It's kind of a unique name for me.
Where does your boyfriend work? He's in computers.
He is at he actually worked at Amazon but right now he's at, they are started a company called Seeker, S-E-E-K-R.
I think I've heard of them. That name sounds familiar.
Seeker? What they're gonna do is they're trying to build something where they can
start recording button.
Okay.
Misinformation.
I am, yeah.
So, but I don't know. My thing with that
can-
is like the people who are building this stuff.
Yeah.
Input. Like this is where DEI comes in. Like who gets to decide, what is what, how to categorize.
Okay. Well, that's part of, I think, the work that Chaos is doing with some open source projects is laying those ground rules down, setting those expectations. Because if you come into an open source project and you have no idea who's making the decisions or why the decisions are being made, it's very alienating.
But if you understand what the ground rules are, there's a framework, and the project follows their framework, then it's much more inclusive
I
because
should ask him if there's such a thing, because I see him struggle with being alienated sometimes.
oh yeah, definitely. You should definitely, if you're really interested in this open source stuff, I definitely encourage you to look into the Chaos Project. I think it would be a good fit. Sure.
I will look into it. I'm a little bit overwhelmed to know about everything, but I think, a little at a time,
Okay,
it doesn't have to be all of a sudden.
Well, I think you jumped into the deep end of the
I
pool.
did.
And
It's
I'm
like,
like
I heard
being
someone
streamed,
talk-
I think you're brave.
Oh, yeah.
You're very brave, but I
Yeah,
would say the Chaos
so-
Project might be a gentler on ramp.
And I also heard someone.
Okay.
They were saying something like.
Yeah, so just talking to the mic.
Hello.
To know everything, just give.
Hmm,
Go after, like what you said, what your passion is, just kind of pursue what interests you and specialize in that. You don't have to like know all.
And I think it's okay just to let it
Oh.
wash over you too. You know, I
Mhm.
mean, like, I've been bopping around from session to session, and
That,
know
I can't
what
tell.
they're
Oh, sorry.
you know,
Test, test, test. No, it's totally my fault.
language wash over me, the concepts wash
I think
over,
that
and
sounds
you know
good.
what? It'll eventually
It'll
it'll eventually knit together. You know, as I do more research and learn more and read more.
Cool.
And
You ready?
all that good stuff.
Yeah.
Awesome.
I'm just chilling.
All right, you're good to go.
Somehow we keep track of things in our minds.
Okay, hello everyone. Thank you for coming, and also thank you to everyone online that is tuning in. My name is Christina. Today I'm going to be talking about one of my favorite things in the whole world, which is hackathons and my experience organizing one and what a hot mess it was. So hopefully you guys can learn from my mistakes. So for those of you who don't know what a hackathon is, it's essentially an ideas marathon. So it's a place for programmers, designers, and basically anyone to come together, build, innovate, solve problems intensely and collaboratively for a limited time frame. So you're not sleeping for 24 to 48 hours, you're just coding with your friends. So what good are they? Why do I care about hackathons? Are they worthwhile? And yes, so a lot of people say that hackathons are where they've met a lot of their mentors. It's a great place to network. Not only that, it is a place to learn new skills. At my first hackathon, I wrote something in JavaScript for the first time, and then I added it to my resume, which immediately led me to my first internship, even though I only coded it in 24 hours. And then building stuff too. So 75% of hackathon participants were pretty proud of what they've built, even though they only coded it for 24 hours. So my personal experiences. HackSB was the first hackathon that I ever attended. And I quickly got very addicted to it and attended over 10 in the course of like a couple months, which was very bad for my health. But, I was younger back then, about 20 years old, so I could, pull all-nighters and drink 4 cups of coffee a day. So after a while, I decided to co-found Hack Davis, which was my university's hackathon. And after that, I graduated and decided to use my experience organizing hackathons into my current career path. And this is me at my first hackathon, and this picture is pretty deep fried because I took it with an iPhone 7. But yeah, this is me after like 24 hours of no sleep, and me and my team, and we're having a great time. Yeah, so let's talk about Hack Davis. So back then, in 2016, every single UC in the University of California system had a hackathon, except for UC Davis. And I asked myself, okay, well, is there anyone planning on making one? The answer was no. So me and a couple friends, we were playing pool, and we just randomly decided, okay, well, if no one's doing it, then we should totally do it. And that's how it got created. And I think the reason why we didn't have one was because at the time, our CS department lead straight up told us, I don't believe in hackathons. I think they're a waste of time, and we're not going to give you any money, so good luck. So it was pretty much an uphill battle from then for us to get the approval we needed, for us to get like the approval from like the school, because obviously they were very suspicious of us, having students sleep overnight on campus and not sleeping, stuff like that. So besides that, I wanted to go more in depth on what exactly that entailed and my journey through that. So what are the parts that make up a hackathon? By then, I had attended maybe like 10 to 20 hackathons, and we determined that these were kind of the different areas of management that we needed in order to throw a successful one. So we split them into technical, marketing, sponsorship, design, operations, and financial. We sent out a list to everyone in the computer science department, to all the students, and we're like, if you want to come help, please come help. And we had an amazing 15 applicants our first year, so which was not great. But besides that, everyone that applied truly believed in the project, and we were able to get it off the ground. So first one I'll be talking about is technical. The technical team worked on finishing the website. We had a sponsorship section, an FAQ, how to connect to us, and this was pretty important because this was essentially like the face of our event, right? When sponsors would look us up, this would be the first thing that they saw. So we definitely had to make something that looked really neat, that had a good impression, that kind of made us look professional somewhat. We also had the technical team working on setting up the acceptances and taking applications. So that was like a whole nother mess that we had to go through. And for the day of, we also had to set up a Slack for all the participants to talk to each other, so we could also talk to them the day of and tell them, hey, lunch is here, hey, dinner is here, stuff like that. Slack is pretty outdated now. I think a lot of hackathons use Discord instead, but basically the same thing. So this was our first website back then, which took us a long time to implement, and we were so proud of it, and we thought this looked really swanky and really cool until I saw this year's, which looks way better, by the way, and all the images are like custom made illustrations, and they have like a super cool design team now and stuff. So I'm really proud of this year's team, of which I have no participation in. They have no idea who I am anymore. But yeah, so really important for you to like have a really cool website to kind of wow the sponsors with, to kind of show them, yeah, we know what we're doing, even if you don't. The next part I wanted to talk about is marketing and design. So the first thing we did was create a bunch of workshops and a content schedule to get students used to Hack Davis and to build a community culture around hackathons. So this was pretty important because the hackathon itself was only like a one weekend event. So we had to do something the rest of the year to get the rest of the student population to recognize us and kind of respect us and get interested in the event, to kind of drum up support. The marketing team also was in charge of like creating social media shoutouts and presences, as well as writing like Medium articles to kind of, put us on the internet. We wrote tutorials on how to build stuff in JavaScript, how to write websites, stuff like that. And then they also reached out to local newspapers and TV stations to get interviewed. So that was pretty neat as well. So here's like an example list of the kinds of workshops that we hosted throughout the year to kind of get the students interested in us. So although these are a lot like student-based stuff, they could also apply to corporate hackathons as well. Specifically like alumni panels with AMA-style interviews with, alumni, hacking into the tech world, glowing up your presentation. Prototyping with Figma was a very popular one, as well as creating interactive websites in JavaScript. They would essentially teach you how to get your own website live and up in 1 hour. So that was pretty cool. And these workshops helped a lot in getting our name out there and establishing ourselves as a very professional group of folks who knew how to code. And this was me at my first workshop. And I was really nervous, and I was just talking about hackathons the same way I am now. So I just thought it was really cute. I had to go through all my Facebook photos to find this. This was our first Instagram post back in 2016 when we announced that Hack Davis was now accepting applications. And we got a whopping 23 likes. So obviously we were pretty important back then. And this is our Medium account where we posted a lot of stuff on how we built our website, a lot of more technical articles on JavaScript, on our team and how we operated. So this was also just a really cool way for us to get our name out there. Okay, sponsorship and finance, one of the biggest parts of any hackathon. First, our finance and sponsorship team had to set up a bank account as a nonprofit. So this was a great difficulty because the student bank accounts functioned a lot differently than a regular bank account. So we opted to go for an external bank account, which also had its own set of issues because we were a bunch of students and had no idea what we were doing. But we figured it out eventually. We also had to draft up a sponsorship agreement invoices, and we did that by Googling
what does a sponsorship invoice look like? Because once we actually convinced the sponsors to give us money, they were like, okay, can you please send us an invoice so we can send it to our finance department? And we were like, yeah, totally, like invoices, we got one. So we made one, yeah. Figure out where to put the money. We figured that out eventually once we got the first step down. And last but not least, we also had to collaborate with local organizations on campus, nonprofits for partnerships. So when I created this hackathon, I specifically wanted us to partner with local nonprofits because they had a list of issues that I feel like students could solve easily at hackathons. So every year we brought in a new nonprofit, and for example, this year we had Teach for America, and we had one of the representatives come in and talk about the kind of issues that teachers would face in the daily place in the workforce. And a lot of our students, took that as inspiration and hacked to help them with that. So that was really cool. Yeah, so I went through my Google Drive, and this was one of the bullet points in our timeline. Have $30,000 in the bank by March 1st. Easier said than done, right? But we got this. So this was very optimistic. But I just thought this was really funny to look at because it just goes to show we had no idea what we were doing. So how did we get sponsors if we had no idea what we were doing? And when the sponsors reply to you, if you're lucky enough to get a response, they'll be like, can you please send us a sponsorship prospectus or a packet? You have to put together some sort of PDF that makes you look like, a good thing to invest in. So why should you sponsor us? And we are like, you can talk to students here, you get to evangelize your product, and you get to really spread the word on what your company does here. So this was on page 1, and we kind of explained ourselves, like who we were and like the things we did and what we wanted to do. The second page is like the more important page, so sponsorship. These are the tiers for the first year of Hack Davis, how much it would cost for you to really get a table there with us. And we were pretty cheap, all things considered. I know the lowest tier says 2.5K, but honestly, you could haggle with a student. They'll be happy to get pretty much anything. Like you could even donate muffins, and they'll be like, yeah, we'll take the muffins. Muffins are expensive. So these are just rough guidelines, but you can really haggle your way and like mix and match the things that you want. Another big thing that companies were interested in was obviously recruiting. UC Davis back then was not exactly known for a stellar computer science program, especially with UC Berkeley, an hour and a half away. Especially since, UC Davis actually started off as UC Berkeley's farm school. So if you go on Wikipedia and check previous names of UC Davis, it says UC Berkeley Farm School. So we were a lot more well known for our biological sciences and our animal science program. So it was a little bit difficult getting computer science and tech companies to notice us, given like we had a pretty tough competition there. But regardless, our CS program is really good now, really strong. So it's really great to see. And last but not least, branding. Companies want to see their logos on all the shirts. They like seeing their logos on the websites. So every hackathon attendee would get a free t-shirt, and on the back of the t-shirt would be your company's logo. And depending on how much money you gave us, your logo would be bigger or smaller. So that was also something that the hackathon kind of sold in a way to like get sponsorships. You gotta be prepared for anything. There were a lot of things that we did not expect to spend money on, like power strips and power. That cost us $3,000. Security, which makes sense, but we did not consider that at all. So we had to hire overnight security to kind of make sure all the students were safe and secure. Yeah, you just have to be prepared for anything. And after that, every year we had an emergency fund just because we weren't sure, what exactly we had to do. Next, picking a venue. So this is an interesting one. Size and capacity definitely is like one of the first and foremost things when picking a hackathon venue. But something I wanted to talk about more importantly were the amenities. So things you need to consider. Are there enough power outlets? Each hacker will have at least charging one laptop, one phone, whatever. Some people even bring like 24-inch monitors to hackathons. So you just gotta be ready for that. Will you have a stage area when you give your keynote opening presentations? Is there a big enough screen for you to give your PowerPoints? Are there restrooms? Is there a kitchen to put your food? Do you need refrigeration for the food you're giving the hackers? Are there tables? Are there chairs? These things all cost lots of money and you need to think about it, and we did not think about that. Location obviously is very important. You want to be somewhere where all your hackers can come to easily. Accessibility and budget obviously are things you need to consider, and tech requirements. So this one is really funny. I wanted to talk a bit about this one. So this was like where Hack Davis is located now. It is in our Arc Pavilion, which is like a really cool, really big basketball court with like a bunch of seating on the side, as you can kind of see. The only thing is that this Arc Pavilion is made out of solid concrete, which is not great for a Wi-Fi signal. So every year we had to spend thousands of dollars outsourcing an internet company to come in and install like 30 access points because the university Wi-Fi would not be strong enough to penetrate the concrete walls. So that was definitely a thing. And if you notice, there are not many power outlets on the floor of a basketball court. So we also had to contract out the power outlets and then also provide our own power strips. So that was really fun. But yeah, those are things you need to think about when picking a venue. So this was our budget breakdown for 2017. Our facilities costed around 7.6K. Snacks and meals definitely cost the majority of the budget. It is very expensive at 22K for 500 hackers, so this budget is for 500 people. Swag and branding, so t-shirts and bags and stickers. Our emergency fund, as I specified earlier. Wi-Fi, also very expensive every year. All things considered, I think we got a pretty good deal on that. We also decided to donate to nonprofits every year because that's what we were all about. But yeah, so this was pretty much our budget breakdown for our hackathon that year. Yeah, so operations, big one, figuring out Wi-Fi situation. If you're hosting a hackathon in a solid concrete basketball court, this is going to be a big question mark. More often than not, your Wi-Fi is going to go down just because you have 500 people trying to connect to the access points at the same time, all trying to download Xcode for the first time on their laptop, which is like 50 gigabytes. Operations, also contacting the food vendors, making sure we have food that is good for the hackers. You want to have food that is easy for the hackers to pick up and go back to their tables, or else you're going to have an hour line long and very angry students. So obviously stuff like burritos, sandwiches, and stuff that they can just pick up and go. Students often do not have cars or driver's licenses. You will have to contact transportation and bus companies so you can bus these students in from other locations. We had buses coming in from LA, the Bay Area, and Sacramento. So these things all costed a lot of money and was very stressful because we were transporting students from one place to another, and then you have to plan their trip back as well. Volunteers, so obviously we could not run this all by ourselves, especially handing out food and swag. And then also partnering with the nonprofits that I mentioned earlier also fell under operations. Another thing we had to consider, inclusive and fair judging. So there are a lot of factors that you need to consider when thinking about inclusive and fair judging. Clear guidelines and objective scoring are obviously very important. Panel diversity, so making sure that your judges come from a variety of backgrounds and know a variety of languages. Training for judges, so even having like a 15-minute training session for your judges on what to do and what they can expect is really good, and making sure you provide them the clipboards, the training sheets, as well as pen and paper. Sometimes, hackathons forget about the clipboards, and then you see judges like scribbling down notes on like their phone or something, and that's not a great experience. And a couple other things, so just making sure there's multiple rounds of judging for each project just to eliminate bias, and enough time allocation. I highly recommend finding judges from like the local area as well as from the companies. So the companies are really excited to see what the hackers have hacked, obviously, so they also make pretty excellent judges. Last but not least, if you are thinking about hosting a university hackathon, I highly recommend partnering with Major League Hacking. And I say this because they are an official student hackathon league with their own, conduct code. You get featured on their website, as well as, you get access to a lot of their partnership opportunities. And I say this especially with regards to their hardware labs. So they shipped out like a 100-pound pallet of hardware that we were able to rent out to all of our hackers the day of. So here's like pics of our janky hardware lab. But MLH provided all that hardware, and our students were able to hack on like a lot of like Fitbits, for example, which was really cool. yeah, so after all that, we got together, and this was like a couple pics from the hackathon. Once again, shot on the iPhone 7, so the quality is not that great. But this is us after like 48 hours of no sleeping. And this was the first room that we held Hack Davis in, which was not the Arc Pavilion. It was like a small ballroom, which only fit like 300 people. And here are some more shots from the event. We had a lot of Red Bull, so this was a pretty common sight that the students would just chug Red Bull and coffee throughout the entire 36 hours. And this is them hacking, and it was pretty cool. And this was us after the event, and I slept for like 2 days straight after. The attendance for Hack Davis went up every year, so that was really exciting. So the first year we had 350 students go. The next year we had 500. And then the year after when I graduated in 2017, we had 700. And to date, it is still around 700 because that's probably the maximum that we can fit on the Arc Pavilion floor. And about like, I feel like that's a good number to still give like a relatively good experience for the hackers. So other hackathons that you can attend now that I'm graduated, so obviously I can't attend student hackathons anymore. That'd be kind of weird. So a couple other things that I like to participate in every year. So Google Summer of Code is a pretty great opportunity for students. So you can contribute to open source projects over the summer with like mentorship from a Google person. And this is some pretty great experience. But Hacktoberfest is really fun. So obviously that ended last month, a few days ago. But it's an annual event that encourages people to contribute to open source projects. And if you have 10 PRs merged, you get a free t-shirt. So that's pretty neat. And I guess I also wanted to talk a bit about transitioning to work. So after all this experience, organizing hackathons, year after year, there's still like lots of surprises, but it got smoother. Corporate hackathons are like a great way to like iterate on product features, for example. So hackathon ideas at corporate hackathons often actually become product features. So I saw this time and time again when I worked at Amazon, Square, and Retool. So for example, a lot of the projects that came out of our corporate hackathons, we set aside, 2 or 3 days to do a hackathon sprint. Obviously, we did not ask professional engineers to sleep overnight at the office, but they would create product features that some people and the CEO would notice and be like, that's a pretty good idea. And they would get, the budget and the team to execute on that. And that's a great way to, have your engineers break out of the monotony of the 2-week sprints and work on something they think might be really cool. Yeah, so I have 2 examples here. So PayPal has battle hacks in 14 cities where they invite a lot of different software engineers to come iterate on their APIs. And Foursquare, actually, their feature called Plan Your Next Trip, which uses their Explore API function, came out of a hackathon as well. So hacking as a career? I started off as a SWE, but I recently switched into developer relations. And I don't think a lot of people really know about this as a career path that is a little different from software engineering, but still requires a highly technical background. But essentially, it's the intersection of coding and community and building. So my job right now is actually just to code and to travel and to organize events. So I travel to places, I speak at conferences, and I still get to code every day. I write a lot of documentation, I meet a lot of people, but I use my background to teach others how to code. And it's been really great. I really love doing developer relations and making sure, other people know how to code and talking to other folks like right now. So that's been pretty great. And yeah, so that was my presentation. I have a few minutes left if anyone has any questions, but thank you for coming and listening to my story. Yes.
I have a question for you. So I can tell that you can give us really great stories about outcomes from hackathons, but I wonder if you have kind of nailed down a set of more like quantitative measures about outcomes, performance indicators from hackathons that tell you like, okay, we're going in the right direction here with these programmatic elements versus like, oh, if we did the program differently, we get different indicators, different metrics essentially as outcomes. Do you have thoughts about what those metrics or outcomes might look like?
Yeah, so how we would generally measure the success of our hackathon every year, if that's the question. So the question was like, how do you measure the success of your hackathon? How do you iterate on those variables to make sure you're moving in the right direction, right? Okay. So for us, how we accepted project submissions was through a website called DevPost. And essentially the hackers would submit their projects there. They would take a little demo video and then submit it to like which APIs and which companies stuff they used. And this was a really great way to kind of view like, okay, so which company had like a successful prize. So obviously students want to create things that will enter them, you know, for like a free Google Home or whatever. So this was a great way to see like what motivated the students. A couple companies offered like internships, for example. So that was also like a very popular prize and it got a lot of students excited and interested. Besides that, you know, there was one year where our internet went down for like 6 hours and people obviously like left because, you know, they couldn't hack or do anything in the basketball court without any internet. So that was obviously like not a great thing. And the year after that, we like made sure to pay extra to make sure that like our internet was solid, because the year that happened, obviously we didn't get as many project submissions because people just gave up and went home. Yeah, so there's a bunch of different factors, but essentially what we narrowed down the success to essentially was having good snacks, having good prizes, and making sure the hackers had all their needs met so they could just focus on hacking. Yeah. Yes.
What are some of the things that attract sponsorships? Like, what are some of the, you touch on a few of them, but like, what would you recommend to attract more sponsors? What are the things that interest them to invest in the hackathon?
Right. So the question was, what interested sponsors the most in sponsoring your hackathon? So that's pretty different depending on what each company is looking for. Some companies really want folks to try out their API and to build stuff on their API. This gives them the opportunity to really showcase their API on their own company blog or on their own company website and say like, oh, look what these students could build with our API in a few hours. Other companies are actually looking for like recruiting for their internship program. So it really varies what each company wants. Generally, what people are looking for, I think, is exposure. So it's really hard to measure, but a lot of companies wanted the students to know their names and wanted the students to know what they did. So I think a great example of this is Twilio. They have a really huge hackathon presence, and because of that, I know a lot of the people that attended these conferences, whenever they needed a messaging API, whenever they needed to send text messages programmatically, Twilio was their first choice because it was the one they were most familiar with. And you can see this today. A lot of those students have graduated and have gone on to their own companies, and they still know Twilio and kind of use it as their like first choice. Yeah. Any other questions? I don't know if I can like see questions from online.
I've been checking your archive.
Okay, cool. Well, thank you very much, everyone.
One other question. If
Yeah.
you want to get involved in a hackathon as a judge, what do? Just reach out to the school and say, hey, or their LinkedIn or Slack channel or?
Yeah, I would say like go to the hackathon website and they usually say like, are you interested in supporting or sponsoring us? If you just email them and be like, I'm interested in being a judge, there's always like not enough judges. So they would be more than happy to be like, oh yeah, like we would love to like have you come over and judge.
Okay.
Next talk is a pre-record in here. The other two tracks have talks going, which are streaming and recording. And then when those are done, we have Blender Movie Night. We need. You didn't hear about this.
And we asked like,
We can't leave
is there
anything
anything
here.
that you think we could be improved for next year? I tried to find it for this talk, but I was not able to like access the survey results. But generally the students are pretty much say the same things like the music was too loud at 3 a.m.
I've done everything I can.
I would like to acknowledge the Wurundjeri people of the Kulin Nation, on whose land this presentation was recorded. This is and always will be Aboriginal land. Their sovereignty was never ceded. Despite the somewhat idiosyncratic nature of this presentation, I would also like to acknowledge the Aboriginal and Torres Strait Islander mentors that I had growing up. Although it's not their traditional type of stories, I would not be able to tell. I would like to acknowledge the Wurundjeri people of the Kulin Nation, on whose land this presentation was recorded. This is and always will be Aboriginal land. Their sovereignty was never ceded. Despite the somewhat idiosyncratic nature of this presentation, I would also like to acknowledge the Aboriginal and Torres Strait Islander mentors that I had growing up. Although it's not their traditional type of stories, I would not be able to tell stories the way that I did if I hadn't had the benefit of their teachings. Good day to you all. It is wonderful to see you all here today for this briefing on cyborg security. I hope that you all found the briefing centre all right. Now, before we commence, there is some additional data which all of you are going to need. If you wish to take out the devices with which you have been issued, you will find them in your pockets and scan the detailed information which is up on the big screen currently. You will be taken to all of the additional data that you need in order to follow along with this briefing. So you want to be a cyborg? Well, you've come to the right place. I myself have many years of experience, which is up on the big screen currently. You will be taken to all of the additional data that you need in order to follow along with this briefing. So you want to be a cyborg? Well, you've come to the right place. I myself have many years of experience in both medico-cybernetics and recreational cybernetics. And if you're wondering how I got that, well, the simple answer is I've been involved in cyborg communities for many years, and what I hope to present to you today is an honest briefing on the benefits and pitfalls, if you will, of becoming part of the recreational Internet of Things network. Now, when I talk about the history of medico-cybernetics, my experience is not just in the low-tech augment medico-cybernetics field. I have, in fact, at various points been hooked up to many devices, some of which have at points been life-sustaining, and others of which have been more used for their advanced monitoring functions, shall we say. Now, the thing that's worth understanding here is that even those devices which are used for advanced monitoring functions do come with pitfalls. The point at which you bridge the gap between simply augmenting yourself physically and deciding that you wish to connect yourself up to the Internet of Things network is the point at which you need to become much more careful about the data that you might be transmitting and how that data might be used. Now, I'm not just talking about this from personal experience here. There has in fact been a lot of great work done by the folks at the independent broadcasting station ProPublica. You may have heard of them. It frequently appears that as far as many people in our circles, shall we say, are concerned, ProPublica would be the nuisances. And they've done some really good deep dives on the matter of cyborg security. It turns out that as we are progressing towards the technological future, in some cases we have, shall we say, advanced features at the expense of general safety, which is always rather an unfortunate outcome. This has been very well illustrated in many people who have experienced augmentation. One of the early use cases for Internet of Things enabled augmentation was in fact pacemakers, and there are many people who have explored the security constraints of those sorts of devices, including ones who have them implanted in their own bodies. Now, the benefit there of the augment is clear. If the heart that one is issued with by default does not work, it seems only logical that we should in fact replace that with a technological equivalent. However, when the technological equivalents are used for other basic functions, such as communication, the risk-benefit ratio can occasionally be less clear, including in cases when the augments catch on fire, which in technical parlance we would call not recommended. But it's not just augmentation for profit that we're here to talk about. We're also here to talk about augmentation for the purposes of fun. And there are many, many ways in which one can recreationally explore this, recreationally hook oneself up to the Internet of Things network. You can look at everything here from augmenting features which are not considered essential but which one might have missing. A great case study here is the practice of hearing color, which was popularized by one of the very early pioneers of the legal rights of cyborgs, a gentleman who augmented himself by attaching an antenna to his head to allow him to perceive color and overcome the deficit, depending on how you look at it, of a chromatopsia with which he was born. And then there are scenarios which are just far more recreational, like the idea of being able to unlock your whole house with an RFID implant in your hand, or putting an NFC chip in yourself and then downloading all of your financial data onto it and using it as a single source of truth for everything. One of the crucial differences between medico-cybernetics and recreational cybernetics is obviously the paradigm of necessity. And in that case, we're going to talk about medico-cybernetics first because it's the scenario which presents the larger number of pitfalls. If you find yourself with a medical need for augmentation, as I have done, and as many others have done throughout their lifetimes, one thing that you'll learn very quickly is that in this future towards which we are progressing, you don't always have quite as much control as you think you should, or certainly as much control as you might want, which has been very well illustrated, particularly in the case of hackable hearts. If one finds that one must have some sort of augmentation implanted in order to replace one's originally issued heart, then one of the pitfalls that one will run into very quickly is that not only does one not have control over the piece of hardware, one might not even have access, well, one almost certainly won't have access to the underlying software running on the hardware implanted in their bodies. This has been explored by a number of people. It was explored at great length by Karen Sandler, another pioneer of early cyborgs. It was also explored by a couple of journalists who themselves had direct experience of this. But the use case here which is most illuminating is in fact the one which was brought to the forefront of consciousness by ProPublica. This specifically being the use case of an obsolete device being implanted into the human body with no way to remove it. This is what we call, in parlance, a fail-deadly safety. One has to have this thing implanted in one's body to substitute for the non-functioning or malfunctioning organ with which one was issued at birth. Unfortunately, when the augment fails, the consequences can be just as catastrophic as the originally issued organ failing, if not more so. To put it in plain language, the human heart, when it fails, does not generally catch on fire. This has been a known issue with some of the augments which people have had implanted to replace malfunctioning hearts. There's a bit of food for thought. The problem is that recreational cybernetics has a similar set of pitfalls. They're just often not as well enumerated. how hard would it be for someone to hack that NFC chip that you got implanted in your hand to augment all of your financial data into a format which you couldn't lose? I mean, I'm probably preaching to the choir here. I am sure that many of you have lost a certain piece of plastic with a certain chip that has financial data encoded into it at least once in your life. But if we find that that particular piece of plastic has some sort of critical security flaw, there is a very simple way of dealing with it. We take out a pair of scissors, we cut it up, we put it in whatever disposal receptacle we have handy to us, we acquire a new one, and we continue on our day. Once that data is stored on an implant which is in someone's body, it requires further augmentation to update or remove. Which brings us to the first critical paradigm of cyborg security. Understand how your augments will be updated and secured continuously. We live in a world where technology moves at great speed. It seems that any time you turn your head, some sort of new vulnerability in some sort of critical system is disclosed, and everyone finds themselves falling over themselves to fix it before the whole cybernetic system performs the great collapse. That's rather easy when all that you have to do is pull some chips out of racks or connect whatever system you're dealing with to the internet and run some updates. It's less easy when updating augments, because updating augments, if you do not have a way to connect them, requires surgery. The second critical paradigm to talk about when one is dealing with cyborg security is not just understanding the security of the software, but understanding the security of the hardware of the augments which you will be implanting into your bodies. That case study that we were talking about with cybernetic hearts, that's a particularly fun one because the issue with the augment there was actually a hardware-based one. It was not the software of the augment which was blowing up, it was the hardware that was inherent to the system as it was built prior to implantation. And that can cause all manner of problems because, again, once it's in, it's rather hard to get it out. The critical piece of data to bear in mind here is that the smaller the device component which is implanted under the human skin, the easier it is to hot swap components should one discover hardware vulnerabilities. So if we take another early example of medico-cybernetics in insulin pumps, a case study which I have explored many times in the past in terms of general software and hardware augmentations, one of the things that one will notice about the insulin pump as a case study is that there's actually very little of it which is implanted into the human body. The vast majority of the augment is outside, and this means that if one cleverly designs the augment, one can hot swap parts almost at will. This is much harder when one is dealing with something like a pacemaker which must be implanted under the skin for a significant period of time, and indeed is a type of augment which lies wholly within the human body. But then one runs into edge cases like the case of the artificial heart, where parts of the device are implanted within the body and parts of the device are externalized. So again, the thing that I would stress here for those of you who have a specific interest in medico-cybernetics, whether it be in designing such devices or whether you're here because you're about to have one implanted in you, is to understand how much of that device is externalized and understand how much of that device can be hot swapped and replaced at will. Even if the answer is not favorable, understanding that will allow you to run a risk-benefit equation, which will make you a much more informed cyborg as you go through the process. Another salient point to highlight is the fact that if one is engaging in recreational cybernetics, in hardware terms, there are a couple of different ways in which one can do this. One can walk into any Augment supply store, purchase some sort of NFC or RFID chip off a shelf, hack around it however one pleases, and then find some way to insert it into one's body. Bam! You are augmented. Welcome to the ranks of the cyborg. But in other cases, one might be dealing with kits which are solely off the shelf. So another critical thing to understand if you're interested specifically in recreational cybernetics is not just how much of it is implanted in the body, but how much of it you can engineer yourself and what your confidence interval is compared to the confidence interval of manufacturers who work with these sorts of augments all the time. If you are indeed a skilled hardware modifier, you might find that your comfort level is very high, and theoretically, you would then have a scenario where you could build and implant an augment entirely by yourself using hardware blueprints, which could then be made available to anyone in any location on any planet. And even if you are not entirely certain whether it has flaws, any hardware flaws which exist will be discovered rather quickly once you publish the schematic, provided that you manage to get a sufficient number of eyes on it. Whereas if one is dealing with an off-the-shelf manufacturer, the confidence interval may be higher, particularly if you're not an experienced hardware augmenter, but you will have to contend with the fact that those schematics are often not publicly available, and therefore those sorts of augments don't go through the standard vetting process that would be expected from cyborg initiatives which are run solely by the community. Now, back to the software for a moment, since we're talking about the recreational aspect of it. There's an assumption that even if one doesn't control the hardware of a recreational implant, one will have a reasonable amount of control over the software that it runs. If you're dealing with something like an RFID or NFC chip, this is obviously not going to be particularly advanced, but if you're interested in more complex recreational augments, you might find yourself building a significant amount of software or modifying a significant amount of software off the shelf in order to get the augment to do what you actually want it to do. You may also find that you come into it with a particular view of how it's set up, and that what you want to do is actually not possible, and this brings me to the topic of managing pings. Our hardware and our software evolve. As the cyborg community builds augments, those augments become significantly more technologically advanced. An important thing to understand here is, what are the capabilities going to be in 10 years' time of an augment which is placed in your body now? If you feel that you want to take advantage of more advanced capabilities, are you going to end up in a solution where, because of the software overhead which is required to run them, you're required to modify augments or augment yourself again? These are all important things to understand. And then there's the necessity of, generally, if you want to go beyond augmenting and actually connect yourself to the human Internet of Things network, understanding that you will have to manage pings, you will have to manage public connectivity, and set up some sort of security to ensure that everything that you are doing with your augment is not world readable. That can go very badly, believe me, I've looked at some of those devices. And on the medico-cybernetic side, part of managing pings means accepting that you probably won't actually have access to the code, and you might not even know what it's doing. One of the journalists who became very well known for writing about his experiences with early medico-cybernetics devices, including a hackable heart, noted that all of the professions on the medico side of medico-cybernetics that he was dealing with expressed a great deal of discomfort when he finally decided to shut himself off from the Internet of Things permanently and simply turn off the update function of his hackable heart. That's a trade-off that each cyborg should be able to make for themselves. There are times where you may want that connectivity to be available. There are times where the risk of being hacked is so great that you pretty much want to just shut the connectivity off, where the risk of being part of the Internet of Things might mean something to do with human safety. Doesn't really matter how much you augment yourself, although metal is admittedly better than meat, we still will have to deal with some degree of meat sack. The worst case scenario, regardless of whether it's hardware or software based, is a hostile takeover. This is where some sort of malicious actor wrestles control of your augment away from you. In some scenarios, that malicious actor may be another meat sack. In some scenarios, that malicious actor may simply be a rogue computer. And in some scenarios, the malicious actor will be the device itself, as we've seen in the case of the hackable hearts which catch on fire. Hostile takeovers are probably the worst risk scenario for cyborgs, because they may necessitate total device removal. Now, my personal experience with this is as a cyborg whose augments are external, but I can certainly say that this is something that I have looked at in the vetting process of many of the machines that I've been attached to at various points. So be aware of what the signs of a hostile takeover are. As much as we are all here for the purposes of augmentation, it's still critical to listen to the meat sack, understand the failure states, understand the warning signs, and do bear in mind that any hostile takeover scenario may ultimately require device removal. Be prepared for that. Understand that. I hope that this briefing has given you some information on whether you wish to embark on the journey yourself of becoming a cyborg. At the very least, if it is a journey that is to be thrust upon you, I hope that you now have a more informed understanding of the risks and benefits of doing so. If I can leave all of you in this location with one takeaway today, the takeaway that I would like to leave you with is experiment yourself. And this begins if you're in a medico-cybernetic scenario dealing with a device which you have little to no control over and are unable to modify. This begins with understanding what the limits are, making frequent requests for data, speaking to all of the various companies which produce medico-cybernetic devices for your particular use case, and recruiting professionals on the medico side who have a better understanding and are willing to work with your assessment of the risks and benefits. Now, if you're going into this purely recreationally to enhance your capabilities in some manner, rather than to replace capabilities which are actively harmful to you, then the important thing to understand is that as far as you are able, you can hack these devices yourself. In fact, if you're in a medico-cybernetic scenario and you find a particularly willing manufacturer, you may even be able to do that yourself. Test the limits of it. I talked a little bit earlier about insulin pumps as one of the very early case studies, and they are a brilliant example of the cyborg community coming together to produce augments which would not have been possible without experimentation. Again, I have given briefings on this before. If you're curious about what the whole story is, go and see those. It has been lovely to be here to talk to you all today on an area of some expertise of mine, and I hope that regardless of whether or not you become a cyborg in future, you leave this briefing today informed and with a deeper understanding of the challenges that face us as we move towards a more augmented future.